All right. Let's get that YouTube feed in there. Where is that? There it is. Grab this thing. Hop out the chat. Bada bing. All right, so that's gonna get all of our chats on screen. I'm back. I'm back with a lot less blood in my body. But by design. I'm supposed to get blood drawn every 6 months because I have high iron levels. It's a genetic thing. But I had that done on Monday, and I got a huge bruise, like big bruises where they did the blood draw. They really fucked me up. So I took Tuesday off to do health insurance stuff as well as get my shit together. How do you draw blood? Yeah, you need markers, red markers. Whoa, we didn't get to, hold on. Microscope, calibrate. Pew, pew, pew. Camera arm, calibrate. There we go. Yeah. Look at the RC car. Look, look, look. Look what I did to it. I designed a fully plastic top bar so that I could avoid the screws and stuff scraping all the center things. When I put screws in it, the grub screw that holds on the little hub in the front was hitting up against the screw was hitting up against the grub screw that holds the front like axle thing on. So I had to scrape down the grub screw, and then I decided to just redesign the entire top bar in plastic. Plastic is not going to be as rigid as the carbon fiber, but it certainly lets me pack things up nice and neat. So pretty cool. Yeah, and it has wheels and tires. These are from the WL Toys kit, and the tires I bought from Wolfram. They were the only ones that were like this and in stock. So hold on, I got to turn down my feedback when I do the uploads. Also, how's it going, Mega Science? How you been? Yeah, when I do the video uploads, I need that volume to be up so I can hear what's going on. But yeah, this has come along nicely. The only thing that I don't know how to do now is tuning the suspension, like the steering arms and stuff, the control arms, because those are reverse and forward threaded into plastic. So all I need to do is get a tool in there and twist it, and it'll pull in and out the wheels. But I don't know what setup I want right now, because I've been trying to do maximum speed, but for my testing I've been driving it in the little open area I have right behind me here. So I don't know what tune I want on it, and it's not drifting. It is picking up all the animal hair in the shop. It's kind of a Roomba. Been perpetually sleepy. That's been my adult life, and the cause of it is a couple things: high iron levels in blood, diabetes, bad sleep schedule, snoring. So I probably should be on a CPAP machine because of my weight, but I think if I'm getting the iron thing under control, and if I can do that, I mean, also low testosterone has caused problems with sleep. Like when I was taking testosterone, I'd be like, it is time for bed, and go, and then wake up and go, I feel like attacking the day. It was crazy stuff. But yeah, I've got several things that make you chronically tired, but I'm getting a handle on it. I got to get rid of these bags under the eyes because I've had those for like 2 years, 3 years, more, my entire streaming career. It's ridiculous. I'm looking at all these old VODs. I'm like, I look like shit. I gotta do me. I gotta fix me. Dog has helped a lot though. That's had me touch Grassington almost every day. The RC car helps. It keeps me distracted. Yeah, this thing is incredibly smooth. I mean, just from I've been driving it around like in this area here, this open area, and there's not a lot of space, and this thing perpetually slides around in spite of the nice soft rubber that it has. I am excited to take it outside at some point. It's gotten very warm here, which is a little concerning in, March, but I want to see what the top speed is like. And then whenever something blows up when I'm doing the top speed run, I will order the spare parts and get the wider tires so that I can actually do some serious runs. This is designed to have the body shell go over it. That's why it's so narrow, which makes it just kind of slide around. I thought this would be a dumpier car body. I wish it was. I wish it was a dumpier car body. I wanted to have it look like a Prius or something really boring and beige. But yeah, this thing is crazy. It's super duper fast. Compared to the WL Toys, I don't know, the WL Toys could probably take it for a run for its money, because these motors are all the same in all these RC car kits. They're way, way overpowered for what they are. You can, I mean, like, it's all down to like how you tune the suspension and stuff. Put a Woody on it, that would be kind of cool. Or if I could find my completely dumpy, normal looking, although to be honest, the kids are starting to get nostalgic about the type of car that I have, which is weird because I hated this era, the late 90s era of jelly bean cars, because everybody got CAD software suddenly that could do aero, and all of the evidence of aero pointed towards bloated jelly bean shapes. So they took their signature look, all these car companies, multiple car companies did this. VW is especially guilty of this. They took their signature look and they made it all bloated and jelly bean like, because the aerodynamics caused, you know, fuel mileage to go significantly up. So the car that I have is of that era. It looks like that. So if I could get a body like that for this car, it would be hilarious. Just a station wagon that looks all bloated. No, it's well, maybe, but it's mostly, it just gets caught in the axles. I can take the wheels off and just get all the hair off, but it's not really all that worth my time. Because I don't have enough room to do like a course. I could do like a bit of a carpeted course, but it's not, it's all narrow hallways. We've got a lot of stuff in this house. What's up, RYG? Hey, Commodore. That's right, it's Pi Day, 31424. Nobody knows pi in that many digits, so 3.1459. So it's not 1959, so we can't do a full Pi Day. We missed that. It was a long time ago. Lead cars with a souped up Roomba. I just have what did they do with the? It was one of the cheap motorsports competitions. I think Grassroots Motorsports did this. They actually did it in a real race too. They had a Corvette that had these rubber skirts, and then it had a motor that was sucking it to the ground for extra grip. And I think a Grassroots Motorsports, one of these, it's a magazine called Grassroots Motorsports, started by a bunch of Miata guys who just wanted to talk about cars all day, and they get to now. But they, for one of their competitions, somebody did the vacuum the car thing. So they put a leaf blower in the middle of the car, and then they put shitty side skirts all around, and they were like, it's shockingly effective. What's the heaviest component on that RC car? It's between, I think it's got to be the battery at this point. The battery is not super heavy, and it is lower to the ground than the other ones I had. These are a little bit higher up. Not that that makes that much of a handling difference between these two, and these have more capacity, but these ballooned, and I wanted to find a different battery. These are technically drone batteries. And also, these don't have two plugs on them, so I had to modify the charging setup so that it had those and the balance thing. So all I have to do is just plug that into my charger. My charger is so obnoxious, though. I probably should get just like a cheap one. Just a cheap little USB charger or something for these. But yeah, I think this is the heaviest component. This one-piece plastic bar is something that I did. There are two screws that are under the motor, the speed controller, which is really annoying. You have to pop the speed controller up, undo the two screws that anchor the sort of Y adapter of the steering. I don't know if those could become grub screws so that you could only undo these four, because structurally having two extra screws right here probably isn't doing a whole lot. RC car loses the battle of the bulge when it catches fire. That's a strange comment. I don't know. Why are we invoking the battle of the bulge? Are you just saying because this bulges out? Well, there's signs for some Battle of the Bulge memorial near where my old house was. It was a weird one. Or no, was it Battle of the Bulge? I don't think it was Battle of the Bulge. It was a different one. I forget what it is now. Actually do forget. Huh. It's yeah, the drone batteries have given it all of the worst ideas, and it will this thing will attempt to fly away. Don't get me wrong. This motor, this 9500 kV motor, is very much missized for this model kit. The other motor that I have is probably a much better model considering the default pinion that they give you. This thing tries to go as fast as possible, which is not what these cars are for. I mean, yeah, any race car is going as fast as possible, and this is absolutely a professional car kit, but you need to size the motor better than this, because this thing will take the model to, like, I don't even know. I haven't calculated it. It's probably on the order of 75 miles an hour, which you will not do on a carpet track. So you need to size your motor more precisely so that you get all that low-end control. But I want to see this thing go as fast as possible. And in doing so, it will then become like its drone battery and fly away while spinning. Control more than speed is absolutely it, yeah. It's not a drone motor. This is a car motor. This is a specifically, I mean, I don't think anybody's doing, you do drones with outrunner motors, not these. You can do RC boats with this kind, but they spin really fast. They're sort of, they're still three-phase, but they're, you know, inverted from what the normal one is. Are you putting your old ABS module on it? I have a couple ABS modules for my big car sitting in a closet, and that might actually work in here, even though the electronics are the size of the entire RC car. It would be kind of hilarious, though, if you gave it authority over, like if you take the chips out and then give it authority over the thing and fool it into thinking that it's in a real car. But there aren't individual brakes. You can't do that with this. What we do have, though, is a gyro. I do actually have a gyro, which is new and novel to my 2000s car, having a gyro in it. There are two gyro modules in that generation of BMW. One of them is a physical gyro. The other one is a digital gyro. And it's, boy howdy, if you have the physical one, are you in trouble when you have to find spare parts. Add a thruster. I've done that before, actually. I put an Estes model rocket in the back of like an old toy RC car, not this kind of like frame car. And I mean, it worked. It wasn't that spectacular. Actually, there was no RC to it. It was just a free, I made it a free rolling thing, and then I set off the model rocket, and it propelled the car. It just wasn't that exciting because the car had a lot of mass to it. At a ramp, watch it fly to the moon. Yeah, it's like a projectile at that point. Bluetooth, no. These have their own type of communications. Well, I mean, it's a known like radio scheme, but it's oh God, what is it called? I don't know. You'd have to look it up. There's a couple different ones, and the one that Short Lurker's using is actually a much more advanced one that actually has telemetry. So you can see what your model's voltage is, and you can have things like an acceleration meter, and you can have a speedometer and stuff like that. It would be nice to do that for this, but that remote, that controller, costs $300, and I don't want this to spiral completely out of my control. This sort of foray into giant man baby toys, aka RC cars. I don't want to spend all of my money in this world on that. Instead, we have a different, completely expensive hobby. Multiple super expensive hobbies, including a force feedback gaming wheel that I need to justify the cost of by doing more streams, burn the subs, which should pay for some of this crap, and a modular synthesizer, which hopefully can make me replace the music that you're listening to right now on Twitch. Hey, Non-Zero Day. Oh, we're gonna get into coding, and my eyelids are already heavy, so this is gonna be a hell of a day. SDR? What is that? No. Physical gyro requires a closer investigation disassembly. Yeah, I don't have one. My car has the digital gyro. I think my Night Scout is full, and I need to upgrade the version. Oh boy. I have so many software tasks that I have been avoiding. Oh, software-defined radio? No, it's nothing like that. Man, Commodore, you're a hammer in search of a nail right now. You're blowing this all way out of proportion, my man. Yeah, software-defined radios are a lot of fun. That's a totally different hobby than RC. This thing is the FS GT3C, so it's digital proportional. I don't know exactly what that means because I haven't read up about it recently, but the protocol is, I don't know, it's a one-way protocol apparently. Actually, I think it is two-way, it's just it doesn't carry extra data like telemetry. But we've hacked this radio in streams past, and now I've got all kinds of tuning features in there. This thing is, I have no need to look for the model up of this radio, which is the $300 touchscreen one that does have telemetry. I'm not doing that. If I do anything with telemetry, I'm gonna have to come up with it on my own. I think so. I think it is that advanced. I don't know what chip it's using, but you could also just take over the LCD and then have that play Doom, which is mostly what those does play Doom. Why are only 3 of my wheels touching the ground? I don't know if this is an entirely flat surface, but I definitely need to look into that. That's a little strange. You at least want 2 front wheels, right? Because if you're hiking a wheel, then it doesn't have any rolling resistance and it'll not roll forward. Or is it sitting up on something? No. This thing is entirely different from the WL Toys. Let me get the WL Toys. I got that sitting in a bin. This one is currently housing my other motor, but one has truck wheels on it, and I also need to finish, you know, fixing things like this. That's a little bit of toe-in back there, I'm sensing. Just a little bit. Although this is not attached. These are freewheeling right now. Oh no, these are attached. Yeah, there's no suspension currently because this linkage is a little bit too long. It's a little bit too long. This is one of the things that sort of broke the camel's back. But the WL Toys kit is so different. I've done so many weird modifications to this too that it's just no longer resembles the WL Toys. But eventually I'll get to kind of fixing this thing up. But yeah, this is one of the big mess ups that I had. This is also the motor, the slower motor. I need to put a header on that so I can potentially use it in there. But this is so different from the other one. So different from the other one. This one has adjustable diffs, but you can't really get to them to adjust them. There's a hole right there where you can get to a screw and actually adjust the differential. I think you could pop a wheel off and adjust the diff on this, but and then I tried to convert it to using 4 of the A-arms. Some of them aren't quite put in correctly, so I need to fix that up, shorten this linkage right here. This has a lot more, I don't know, metal replacement parts that were subpar standard. It's got a much larger linkage right there. A lot of differences on this. But the WL Toys started out as a cheap kit, and then I kept getting modifications for it. The only original parts are the battery holder, the motor holder, I guess technically the A-arms, and then I brought back in some suspension stuff. Those are the only original parts. Everything else has been replaced. But this thing I got up to incredible speeds too. Good stuff, good stuff. There are tiny little cameras that you can put on these, and then you can do a first-person view thing, which it's not out of the question for me to do. I just don't want to go outside and have the neighbors see me with weird goggles on, driving a little RC car around, because I'm like a spherical person. Just not, it's not a good look. Why is this so uneven? Is it that the wheels are... That one looks kind of like it's hiked up a lot. Yeah, I need to lower this wheel. A screwdriver for that. The dog hair on everything is really annoying. Julian has a similar sound in one of his songs. Whatever's doing that symphatic type of alpha beta psychedelic funkin'. screwdriver is not working. If it has a camera, you don't need to be out there with it. That could be a creepo in the window. Now you still have to like retrieve it. Because I'll inevitably want to go balls out for fun. And it will end up in a tree, and I have to go retrieve it. Are all four wheels on? Now they are. It's still like all this suspension for like oh, it's still way uneven, huh? For like a millimeter of travel. This is what I get right there. That's it. Weird. All the suspension stuff for just that. This entire thing, this huge range of motion. I guess if you hit like a big rock, this will absorb a bit of it. Stuck to a passing airplane. There are a few. And the crashes are spectacular. That's why this is a very necessary piece of equipment on this model. I probably could beef that up a little bit too. Because if you just hit one of these, Lord help you, anything plastic will break. But yeah, this is just to satiate the RC car nerds that have fallen into the chat because of my stream or two where I was building this thing. It works great. I've been just sort of hooning it around down there on the wood floors, and it's been pretty good. I haven't really tuned it at all. I think, you know, as soon as I take it outside and do like a high speed run, something's gonna break, and I can order the things that kick back this toe in a little bit, because I don't like the toe in like this. I know it's good for stability on RC cars, but I want it to be a little bit more flat just because I want to go as fast as possible. And then I need to figure out how I'm gonna tune 3 differentials. I have absolutely no idea how that's gonna work. And then I don't know, I'm thinking about 3D printing stuff to help me tune the toe in and stuff and get the steering all in right tune. How have I been doing? I got a lot of blood drawn. I had a whole bag of blood drawn. And that's got me sleeping a little better, but I got like big bruises, these big fucking bruises on my arm. She used the giant needle right there and was like, oh, it slipped out. And I'm like, oh, good. Like, oh, maybe I'll use the IV needle that you suggested emphatically earlier, but it'll take longer. I'm like, for fuck's sake, like, please just listen to me. Nobody listens to me. Do the joints have a tiny bit of play? No, well, actually, so in the WL Toys, oh, that was wrong. That was the wrong camera. In the WL Toys kit, yes, everything has play. Everything wiggles and goes weird and has sort of like little bits of play in it. I've taken a lot of it out of this by using, you know, the aftermarket parts, but like look at that. It's ridiculous. Whereas the expensive kit, and listen, it was a huge indulgence for me to buy this thing because this thing was like a couple $100, which is ridiculous for a toy. But I wanted to compare and contrast the two kits. This thing has very little play. It has sort of the expected amount of play for something of this size. Whereas that thing is just all loosey-goosey. So like when you do tune something with this one, it stays there. Like people were talking about the toe-in being to compensate for when you're accelerating, and I guess I can kind of see it by bending the wheels like this. Sort of this amount of toe-in is to compensate for when you go max throttle and it goes like this. But I don't know if you're going to see that much of that. I don't know, maybe it is justified. I do want to tune it out a little bit though. Because yeah, I don't think it's entirely going to go like that. It's crazy, right? I feel like taking it apart and putting graphite in all the dry joints, just to make it super like tuned up and good. If you go to 1/10 scale, then all of your tuning stuff stays in place, right? It's just everything is different at this size. Everything is so much smaller, and all of the mechanical tolerances are still the same. So it like all of the effect of those tolerances becomes heightened. Because of the scale of everything. Everything's a little tiny thing. We're going to be coding, and my face is going to be on camera all day today. Yeah, we're we got a lot of work to do. The Hagiwo code is a lot less organized as I expected it. What the fuck is this? Oh, there's a piece of a stick in my ear. Weird. Oh, my ear was bleeding. Why is my ear bleeding? What is that? It's got a little rough spot right there. Weird. Okay. You ever get those little cuts that you don't even know that they're there until you find a big blood clot because it didn't heal cleanly or it didn't clot cleanly and it keeps doing weird stuff? That's what I just found out in my one ear. What I hate is one of the nurses yesterday or on Monday was asking it like, "Where'd you get this scar?" And I'm like, "Do you want to know where I got these scars?" No. She was like, "What is this scar? Where'd that come from?" I'm like, I don't know. I brushed up against a table. Like, I was like walking by a table and fucking gave myself this huge, like, fucking... Because I remember it was like... I looked at it like the day after and I'm like, what the hell? I had like blood coming out from it. And I was like, just because I walked by a table funny. It's ridiculous. Oh, he's got unknown scars. Mark it in his file. I got bit by a shark. Actually, it wasn't the shark bite. It was the laser from the shark that got me. Is my ear bleeding? I don't think it is. Nah, no bleeding. No bleeding. I've already bled enough. Whoops. Whoops. There we go. All right, I'm hydrated. It is probably time to start. No, RP2040, which I've never worked with before, but we're taking Hagiwo's code and we are turning it into actual code. I feel like Hagiwo took his code and he barely got it working. I don't know if he even got it working on an Arduino, but depending on the revision of the RP2040, the pin assignments were off, maybe. And the problem, well, let me just start and we'll get to it. Welcome, 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 welcome to my stream. Hello. I need to get a haircut. I'm gonna figure that one out in the next couple, I don't know, month. But anyway, hi. I didn't stream on Tuesday because I was kind of bruised and beaten from getting the blood drawn. It's never easy. I always drink a huge pitcher of water ahead of time, so I'm like super hydrated, so that's easy to find my veins, but they're still impossible to find. And so they, against all of my recommendations, they used the wrong kind of needle that was extra painful and gave me a huge bruise on my arm. You can't see it from this angle. There it is. Huge bruise on my arm, and I was just like, I can't handle streaming today. I did paperwork instead. What fun it is to be an adult. I did paperwork, and I got that to the post office and spent a huge amount of money getting it shipped very quickly. Anyway, so that's all aside. We got to get back to what was going on here, which is projects. And we were working on a voltage-controlled oscillator. In a modular synthesizer, well, in a synthesizer, you have a bunch of different things happening. You have a sequencer, you have something that creates the notes, you have filters, and then you have like your output stuff. And what people decided was, hey, all of this stuff you could make into like a common power supply device, and then you can arrange it in any way you feel is necessary. We will call it a modular synthesizer, and we will put it in a box, and it will have a rail that everything goes to. And there's a couple different standards for modular synthesizers. This one is Eurorack. Eurorack is a, what is it, 100 and something millimeters, and then it's got a bunch of different module sizes. I was not really going to get into this stuff. Julian sold me one of these boxes, and I figured out how to make a really good power supply in it because I'm an engineer. And then he gave me a second one, and then I discovered that with the modular synthesizers, what you can do is you can just buy the circuit board, and they have no instructions and they have no extra parts. That's not, you know, you can do this at any level. You could buy the modules directly. It'll cost you hundreds of dollars. You can buy partially completed modules that have, for instance, the surface mount stuff already soldered to it, and it's already programmed and everything, and you add your own potentiometers, and it comes with a front panel. So you do the big soldering, put it together, and it's a kit. And that's like a fun afternoon, right? To me, that's like the most basic thing in the world. It's like, how do I even compare it? What do I compare that to? It's like building a computer now, but building a computer is a little bit more, that's a different experience. I would say building Lego, but building Lego is satisfying in and of itself. For me, though, it's too basic, right? It's too basic for me. I discovered that you can get into this at the level where you just buy a circuit board and there's no instructions. So you got to look up what the circuit is, what the instructions are, how to put it together. I found mutable instruments to be particularly challenging in this regard because you're doing the smallest surface mount size possible and then vetting it out. And I think if I were to do it all again, what I would do is look at the circuit and actually calculate some things based on like voltage levels and stuff, and then you can put it together piece by piece. So you would put together the input, and then you would test it from 0 to 10 volts before you even involved a microcontroller in there at all. Because I blew up one of the microcontrollers, right? So you take it sequentially and make sure that your hardware works, and then you get your software working for it. We didn't do that with this one either. The one that we're working on right now, because I've built up, we're done with mutable instruments, right? So done with mutable, that's the wrong one. We're done with mutable instruments and we've moved on, and I've discovered that because of my inability to troubleshoot analog circuitry and how horribly complicated the analog voltage controlled oscillators can be, I only have one VCO on that synthesizer. That leads to kind of a sort of samey sounding everything, and I'm hoping to get a little bit more complex with it. So I've discovered through SpeedyCat and through also SpeedyCat? No, SpeedyCat linked me to Hagiwo, which is a YouTuber who creates affordable modular synthesizer modules, and that involves perforated prototyping board and a lot of actual like building of hardware, which is totally up my alley. Totally up my alley. It's great. We started on a project like that, and I decided, wait a sec, this is way too disorganized, and I'm never going to be happy with the circuit. I might as well do what I preach, practice what I preach, and actually jump straight to the circuit board building. But we didn't even vet out the circuit ahead of that. We just kind of jumped into circuit board building, and I came up with 2 PCBs. One of them is a voltage-controlled oscillator with 3 knobs. So we have 3 knobs that can control the parameters, a button and 1 switch. And then another circuit board that has 2 knobs, 2 switches, a button, inputs, and 1 output. So these 2 here, these 2 circuit boards, given that they have an RP2040 strapped to them and the analog to digital and digital to analog capabilities of mutable instrument circuits, makes them a little bit more expensive than what Hagiwo intended, but that means that we have a versatile circuit that we can turn into VCOs, we can turn into filters, we can turn into sequencers, we can do basically anything that the microcontroller allows us to do in the modular synthesizer, and all our ins and outs are all ready for modular synthesizer stuff. Yeah, the rounded corners. It's like I have to do that now. It makes them look so much nicer. If you don't have solid corners on it, you make them nice and soft circuit boards. I don't know, it's just a fancy thing to do. But anyway, we've got the circuit that we built up, and then we tried to load Hagiwo's code, and it turns out the code is just, where did it go? Oh, here it is. The code is just a mess. If you need to change, for instance, a pinout. Wait, why isn't this light on? Hold on a sec, I need to, we got new internet here, by the way. We got new internet, and now it's like super fast. We got amazing like gigabyte download. Finally, we've joined the 21st century. But since something changed, my whole intranet goes psycho. There's like a boot up sequence for all this stuff, and I wish I could get these Tasmota devices to remote reset. I should probably look up Tasmota again and figure out where they are with those. They probably solved that issue, but they just have trouble getting IPs. Anyway, so with the VCO, there it is. Yeah. With the VCO, Hagiwo's code is for, I think, well, his Arduino code, I don't even know if he was running. He might have been running the, whatever the other language that this thing accepts. This thing accepts a bunch of different languages and stuff. It does do Arduino, which is where we're most comfortable working, but it does some other like languages as well. And I think Hagiwo coded this in a different software language, and we may need to take some notes from that other piece of software, because the one he did for Arduino was very bare bones, and he was like, this code is a mess. And I was like, yeah. He labeled something that used the digital pin number 1 by putting a number 1 into all the functions in multiple different places in the code. And that's very hard to pick out because you can't Control F the number 1 and find and replace. So that's sort of the struggle that we're doing. Now, I've done a little bit of code work with this code. I've kind of started to rewrite it a little bit. We need to jump basically into it and continue on, because once we get a grasp of how this works, I also need to make the chord VCO. We need to build an entirely different circuit, which will be visually a lot better because these yellow boards are nice. You can really see the contrast between the FR4 and the copper substrate. Unlike black and white, which does not have any contrast between the FR4 and the substrate, and you are forced to use the actual topography of the board in order to see where the traces are. You have to use the emboss reflections to actually see where these traces are, because otherwise they are invisible. Ridiculous. I shouldn't have ordered this color. Anyway, I had to do it. I've gotten almost every other color from Seed Studio, so yeah, they're pretty cool. They're pretty cool. It's easier to see from far away if with that, but I mean up close. Up close, they look really good. Yeah, being able to see the traces is something mainly for troubleshooting. It helps massively to be able to actually see what the hell's going on in your circuit and figure out who's connected to who. Black and white will do that. White boards are very difficult to see the traces on. Okay, so Arduino. Do I have Arduino open on the other computer? I probably do, but let's start it up. Arduino. Now, for the European people in the audience, I am starting early. Our daylight savings sync up, I think, at the end of the week. Is that right? Soon enough. This is the crap that I have to deal with. Look at that. Ridiculous, ridiculous. I feel a little better though. I am sleeping better, so I'm gonna use that to kind of kick off a new version of Arduino. No, file open. Yeah, doesn't that suck? That's what I get for having blood drawn. I have deep veins, I guess. I have no idea what it means. You have to deal with your own stuff. Draw blood with a turkey baster. What do you think they're using? It is essentially just a turkey baster. Now, well, actually, you can do that because it's got a lure lock. Everything is lure locks with medical stuff, right? And that's why I love using lure lock here, because I can actually use my old syringes, the big ones that were meant for filling insulin pump vials. I can use those with just about everything. So I can use them to like take bubbles out of water cooling stuff, and then I've also got the ones for actually injecting stuff into turkey and other meats that we never used, and so I stole those giant syringes and I use them in the water cooling stuff as a precise way to fill things. And then, you know, we use the regular syringes for glues and stuff like that. I know it is essentially bloodletting. The point of the bloodletting is to get rid of the iron in my blood. They basically throw out a bag of blood, and then the body goes, oh no, we're missing a bunch of blood, let's make more blood, and then it dilutes the iron that's left over. I got a way to show something happens at X time, AM or PM in your time. Then a system message just bumped the message up. But the notification has to use fixed epochs. Oh, is that like system time, like January 1st, 1970? Daylight savings changes is incorrect, and I push up the dates. That kind of sucks. You'd think we as a society have moved on from that. What are we opening up? We're opening up the modular synths. I think it's synth. There it is, synth. And then we have the X40, no, not 4046. We have the RP2040 VCO, and I called it chords. That's not right. Hold on. Crimes, bell bands, basic peaks, speak and spell. It should be in here. I have both programs. It should be. Hold on a second. 4046, speak and spells, 3K programs, basics, bell bands, crimes, public, and RP2040 VCO chord. What is that doing in there? That's not supposed to be in there. Actual chord VCO, RP2040 VCO chords. These are the circuit boards. The software should absolutely be in here. Why is it not? Where did it end up? Hold on, I gotta jump over to the, actually wait, file recent. Where are you? Where did I put this? It's gonna take a minute to open up. Save as. Oh, I put it in the 4046. That's in the wrong folder. Well, okay, so I got confused and opened up the wrong one. That's fine. File open. We'll just work out of that. We'll work out of that directory. Where are we? Crimes. Because the RP2040 had a 40 in it, and I saw 4046, and I'm dumb. Hagiwo was using the Arduino code C++. It does work. I think the pins he used are the same as yours, but I can't remember your schematic. Yeah, we'll get to that. I'm doing a code rewrite because I don't understand how it works. I want to know how it works, so doing a code rewrite will really help me understand it. What I'm opening up is the Arduino rewrite, my file. It's going to take a minute to open up. We're doing a little Arduino here, so you guys should know that the way that I do Arduino is related to how somebody starting out with Arduino would be programming stuff, and they're using the basic IDE. No fancy stuff here. We're using the basic IDE because it's what people will use when they open up an Arduino and try to program it from the very beginning, right? And so what I'm doing is I'm taking two programs and I'm looking at how one works and I'm fitting it into the way that I commonly code stuff. And for me, it is a matter of organization and rigidity that keeps me from getting completely lost in my code. So the way that I organize things, and this is very common, and keep in mind, you know, people who code like really like their own methodologies. I use my own, and so people will come in and they will tell me that I'm doing something wrong or I'm doing this way or that way. And I come from a very deeply seated embedded background. I did not learn formally. I did learn a little bit of embedded formally, but that was way back before the Arduino. The minute I graduated college, the Arduino became a big thing, right? I am old. I have become old and it snuck up on me. But anyway, I program from like the hobbyist embedded systems with a little bit of background in electrical engineering and some coding, not really a lot. I came into programming after college, and so now I know Python, I know, you know, C++, whatever the hell Arduino uses. I have a particular way of doing things, and it was forged in the fires of early Arduino code. The accessibility of the Arduino is a very important facet. I hope this is not too bruised, is it? No. It feels bruised. The accessibility of Arduino is first and foremost to this stream and in generally to the way that I do things, because I want it to be accessible. The hardcore coders in the crowd, I know you guys are like the only people that will consistently watch this stuff, but I have reached you. I'm not trying to reach you again. I'm trying to get the people who don't know anything about this stuff and want to see somebody go about things in a way that they can semi-relate or get some ideas about. And if I inspire anybody, that's my goal. Like, that would be awesome. So I don't like ending lines with semicolons because someone I learned code from wouldn't use them. You have to use them in C++. Like in the C languages, you have to use them. You get away with them with Python if you love white space. which is not that bad to me. I mean, people like to meme on all kinds of things, but they managed to make this weird game with limited coding access, do a lot of crazy complicated stuff, which is why I trusted them. Python can do a lot of cool stuff. Like there's a whole embedded thing for Python, like gaming and stuff. So hey, thank you for the follows, everybody. Okay, so let's get to coding. Like, let's get to software. And I'll show you guys a little bit of the method that I'm doing here. So I use equal signs because they're easy visually. I can just scroll through and see wherever there's a big block equals, that's a different block of the code. And if the equal is indented, then I can see that it is something that I'm sort of pulling out and sequestering into a thing, right? Torque code, interesting. So I start with the pins because pin assignments change on a whim, right? And I haven't put any numbers. The number would go there, right? That's where the number would go. The defines don't need semicolons at the end of them, if I recall correctly. Maybe I'm wrong about that. Hold on, I need an example. I need something with a define in it. Open recent. I think let's do like the ornaments and crimes. That probably has some defines at the beginning, huh? I just want to check. I want to check. I don't want to say a wrong thing. Do. Scroll. Okay, that's a lot of includes. They're not using defines. But yes, they are. Wait. Show me a define. Okay, I have no idea if a define has a semicolon after it or not. It might not. Anyway, I'm starting out with the pin assignments because those change regularly, right? And we'll have to determine what pins are what in all this. I've renamed stuff to actually make a little bit of sense here. Mode select, CV in, octave volt in, audio out, panel LED. So I've defined all of these as variables, well, defines, because the defines the compiler will go through and replace in your code with the numbers. So you can have these defines at the beginning and it's not going to use up a bunch of variables. A lot of the way you'll code in the beginning of working with microcontrollers is you use a lot of variables, which is good. You don't want numbers anywhere in your code. As somebody who's familiar with code like this, my eye twitches whenever I see numbers deep in the code. You're not supposed to do that. You're supposed to have it all up in the stuff up here so that you can change things if they need to change. Defines do not have the semicolon. All right, thank you. So yeah, anyway, so all of these are pinouts, so I put them in their own little section. Then we go down and we define all of our variables, and there's fixed numbers and variables, right? I haven't gotten to any fixed numbers at this point, but right now, I only write my ints using strings like 6. What? Huh? So yeah, anyway, variables. I have a big block for all the variables, and where they're sort of defined and or initialized, right? Because you have scope. These are the giant global variables that will be anywhere in the code. You can call on these anywhere in the code. So if you replace one of them with another number, that's going to stick until something else comes along and writes it. Everybody can see it. Everybody can read it. You do want to limit, well, actually, that was an old philosophy. There's two different philosophies. One of them is limit the amount of global variables, keep everything in scopes, and then if you have like a function that you want to use in a different program, you can grab it and move it to another program, and all of its variables are self-contained, right? That's one way of thinking about how to code. I don't know. I don't know if I subscribe to that one. The other one is global variables all the way. Use as many as you care about. So in a microcontroller, we have two different kinds of loops that run. Well, one's not really technically a loop. Microcontroller will go through line by line on your code if it's one thread, and it'll go through step by step and logically execute the things that you program it to do, right? And so what we're doing in the setup is we are getting everything ready to go in a loop that runs only one. It's a function that runs only once. So you set up and loop. Two functions that make every microcontroller do their thing. Sometimes you have all of your code in the setup, and that would be something that just does one task and then sits perpetually waiting for a restart. If you have a loop, your thread is going to go through that loop as fast as it absolutely can. So sometimes in early microcontrollers, you'll put in a delay. When you get more advanced, that's a disadvantage because a delay stops that thread from running entirely. you want that thread to always be running, and you want to execute your tasks, maybe given time limits. Sometimes you want them to go as fast as possible because, for instance, with this, we want it to be responsive, and we want it to have quality and fidelity, and we want it always to be functioning. So there's considerations in that. So I've just barely started going through this code. I've taken all of the variables and I've moved them over. I have taken a couple additional things out of the equations down here and brought them up. Some of chat helped me in my stream project section to pull out some of the equations and get those running. But for now, I'm just trying to get through setup in order to get to the meat of the code. There's more of this. What's that? Oh, that's there just to remind me of what the different pins are. There's still, you know, what do I do with CV in, what do I do with octave in, etc. So yeah, we've just started up our microcontroller and we're going through and we're setting things up. Whew. Okay, so in setup, I have the pin modes being defined. Input pull-up is when you have, let's actually, I need to open Fusion 360 so we have the schematic in front of us. Or do we can just go from my notes, actually. We can just go from my notes and the PCB. It'll be easier this way, believe me. I don't want to open up the entire CAD project. Where'd the folder go? There it is. Let's bring that back over. And let's go into stream and then synth. I need to clean out these folders. How do you test microcontroller? If it compiles, that's one thing. If it does the correct thing, that's another. That's one way to do it. I mean, perforated prototyping board is a wonderful thing to have in the shop. At any level of doing this stuff, perforated prototyping board allows you to, I can just shove this microcontroller down onto the board and then test it out that way. If the circuit is vetted out and I know that the hardware works, then you know you can set up a bunch of oscilloscope tests, or you can make test routines if you want to. You can have it flash LEDs given certain things functioning. But yeah, solderless breadboard. I keep calling it the wrong thing because the Hackaday commenters yelled at me one time about getting it wrong. Solderless breadboard is extremely useful. It allows you to put all kinds of circuit elements down and test them ahead of actually building it. Technically, the place to go after solderless breadboard is perforated prototyping board, and then you build sort of a semi-permanent version of the circuit. However, $5 per PCB these days, you might as well just go straight into the design. It's the processes for making a full-blown circuit board have changed a little bit given the availability of certain processes. And it's hard to tell. In one instance, you do one thing, in another, you do another, right? But yeah, I'm a little old school. The way that I typically vet out whether or not my software is working properly on the microcontroller is to just program the whole thing, load it up, and see if it functions. And if it doesn't, use serial prints in order to give you an idea of what's going on under the hood. There's a lot of streams that are being uploaded currently for my VOD channel where I'm doing that with the much more complicated system on the steering wheel. Yeah, serial prompts. So anyway, in setup, it's important to tell our fingerprints. It's important to tell our microcontroller what the pins are. Since it's generic I/O meaning input/output, you have a voltage level that's available. If it's digital, it won't read the full range of voltage levels. It'll just have sort of a threshold that it'll read a 1 or a 0 on that. And those are stored in a register. You don't necessarily need to know about that. But the 1s and 0s coming in have a bunch of different flavors to them. What you can do is you can in order to save hardware, you can define the pin as an input pull-up, and that will close a transistor that will go to a resistor that will go to positive power. So input pull-up is just a scheme for triggering something, and that means that our switches that are triggering that pin go to ground. It saves a whole ton of hardware because ground is distributed throughout the entire circuit board, right? It's easy to get anywhere you put something. So if you're putting a button down, you can have that button just simply go to ground, and it's like cheating. It's like free. And then you declare it an input pull-up. When you push the button, it will pull that pin down against the internal resistor to ground potential, and all of that current going into the resistor will leak to ground, and the pin will see a 0. So you have like a high value resistor on there so you're not leaking a lot of current. So we have input pull-ups. We have, well, basically these are all the input pull-ups for all of the buttons and stuff. I still need to define the other pins. I don't know what they're going to be yet. Let me just put them down so that they're in there, and I can get these out of the way. So we'll just put these here, and I'm going to go pin mode. And then this will be CV in input. I mean, I know that's an input. That's going to be an input. So pin mode. Oops. Pin mode. Octave volt in. That's also input. That's an easy one. Pin mode. Audio out. That, I mean, technically it's, I could just call it an output, but I don't know if I need to define it as a PWM pin. I'm not sure if I need to do something special there. So let's put that one separate, and we'll just do the last one here. Pin mode panel LED is output. I guess I could just split off the inputs and the outputs, and we'll just roll with it like this and just see if anything needs to be changed at all. So Hagiwo has us actually load micros into a timer. There's going to be some kind of a time function that needs to be initialized at setup. The amount of time between when timer gets defined and we actually use timer is going to be a very, very small slice of time. This is a fast microcontroller. We're not in a slow microcontroller. Slow microcontroller, for me at least, being like your Atmega 328, your original Arduinos, you would have not a significant amount of time. It's way less time than you would think it is, because I mean, we're talking about, like, we're cognizant of human scales of time. This is a microcontroller. This thing is like a bunch of clockwork that runs at a speed where all you'd hear is instead of tick, 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 right? It's blisteringly fast. It's blisteringly mechanical. If you get a defined time and it punches all those numbers into the memory and then goes through all this code, loops back around and looks at the time again, it's like a blink of a second is actually passed. It's sometimes on the order of milliseconds, sometimes on the order of microseconds. It's unfathomable times. So just consider that you know, that kind of thing. It's okay to do this here. Table set. Table set is a function, because setting this internal reference table is a chore. There's a lot that needs to happen here. So in table set, what's happening? Well, we have a function that's missing. So I think I planned on having a table set there. And that's, I think, what this code is doing. This code is doing the table setting. We peeled out a couple of the functions here. Originally, what this thing is doing is taking this incredibly large table of values. This is 1,230 values, and turning it into a scaled table of PWM outputs for the octave that you're in. That is a lot of values there, and I put a lot of work into organizing it, and it turns out it's linear. You can just do an equation to get this table of values. So instead, we put an equation down here. Because see, this was taking that F0 times power of 2 to the blah, 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 and we can just take it as power of 2 and then define the table versus I. It's not hard to do. So now, as for these values and what they're doing, I'm not sure. We may need to read the article that Hagiwo actually referenced, and I need to put links in my explanation up here. So we need to do a little bit of research before I go on. What we're doing here is we are making the tables that will reference how the PWM outputs behave. And I need to make sure that I'm able to figure that out. So let's take that code out of there, and I'm going to make a function called table set. And I usually put my functions below the loop because I'm a weird Arduino-brained bearded man. So void table set, and we're not passing anything into it. So I put curly braces on the function, and then that's what table set does. It writes that table. Breaking things out into functions helps you organize your thoughts and keep your code clean. It's a good way to kind of structure and order things. So this will be functions. Functions. We'll be fancy about it. So on PWM wrap is indeed a function. So I'm going to take that out and I'm going to put it down below. Table set is happening before on PWM wrap, so we put that down there on PWM wrap, and I still have to figure out what that does. So what does this function do? Well, this one creates the, I mean, I could put a little block above it, but we'll just do it this way. Creates the reference table. Select octave. If we have more than 1230, 6 octaves, it becomes unstable. Now, these numbers insult me. They insult me. They should be up top, but we'll deal with this where it is right now because we need to figure out how this code is working in the first place. I can't preach cleanliness and organization without actually knowing how this thing works in the first place. This is, oh God, my rewrite of the table is going to make it hard to read the code. See, Hagiwo just references the pins directly, which I guess I could just put them in here as an initial thing. So octave select. I put 1 and 2 on there in order to make it actually. Let's use tabs. That way I can have all the numbers line up. Push switch 6. And he's just putting numbers in there. I think there's a better way to define these. Oh, I forgot an underscore. That's okay. Listen, I'm going to make a lot of mistakes as we go. And those will come out with the compiler. So live corrections of what I'm doing. See, GPIO set function 2, set GP2 function PWM. That I've got to look into too. That's a library of some sort that's doing PWM stuff, and that's controlled by hardware/pwm.h. So we need to look up how that's working too. The thing about doing a microcontroller code like this is you need to know all of the little ins and outs of how the microcontroller functions. That'll help me get my head straight and actually program this properly. So I don't know if 2 is a pin number or what. GPIO to slice number, and then they define 2. GPIO function PWM, and that's GP2, so I guess that's pin 2. So audio out would be pin 2. Oops, I didn't do those right. 0 and, well, we're going to be rewriting this anyway. We got to figure out what our pins are on our own setup as it goes. CV in, what pin is that going to for us? I have them labeled. CV in goes to P26. Of course, I didn't give it a pin number. I just said P26, but I don't know, maybe in the Arduino code we can actually define it as P26. No, that doesn't work. Well, I could just define it with, I usually comment stuff like this in there just to help me out. And then we need the pin out for the RP2040. There might be 2 versions. I'm just going to go with whatever I find on the internet first. So let's get a browser window in here. We got to do some research. RP2040 pin out. Oh yeah, xiao. Somebody correct my pronunciation on that because I think I'm pronouncing that wrong. P. Twentington. A0, D0. Well, that's not right. Which one is this? This is hardware overview. Do they mention for general I/O pins, working voltage of the MCU is 3, don't overdo it. Power supply, blah, 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 blah. Currently only supports battery power supply, cannot connect to type C while a battery is connected. Pay attention to use. Do not lift the shield cover. Oh. Bootloader mode. There's only one mention of pins though, that's the thing. People were talking last stream about there being different versions of the hardware. I don't know if that affects, it'll affect the schematic, but it doesn't affect the pinout, or does it? I don't know. So let me just get our pinout to match this pinout. So we have octave select 1 and 2. That says P0 and P1. I don't know, because you're able to give it D and A. I could use A0, 1, 2, and 3 when I define these pins. It's interesting that well, okay, anyway, in the hardware thing, it'll tell you what you can use. You need to open up like a text file, but so let's see, what is our, oh yeah, we have adjust, don't we? Define, let's call it pot 1 and 2. Pot 1 and 2 I forgot about. So pot 1 and 2, and we're going to give pot 1 and 2, what are they? Top one will be 1, and that's P. Happy Pi Day. Happy Spam My Chat Day. Nobody's talking, it's okay. Yes, it is indeed Pi Day. P29. Pot 2 is P27. The panel LED, P7. This is why I did this. You guys can tell that I'm a bit of a jaded microcontroller programmer because of the way that I've structured things in my code. Audio out is down here, P2. CV in, P26. Wait. And the octave in is, oh no, wait a minute, that's octave in is P28. Okay, yeah, good. No, that's P28. This one is P26. Mode select. I don't know which one is supposed to be which, but mode select I think is P4 and 3. So P4 for that one. This one is P3. The button is on P6. And then the octave select is P1 and P0. Okay, so now that we've got all our pins there, I can look them up on the picture and get them all right. So octave select, we got P0. P0 is stored in D6. Yeah, it doesn't highlight those, does it? I think I can define them that way, though. Maybe the RP2040 doesn't like that. I can go into the hardware and check. Where are we going? So I need to go to app data. And probably not roaming. Local. And then we're looking for Arduino 15, packages, RP2040, hardware, RP2040, 372, and then boards.txt. I think. Menu flash, menu frequency, USB stack, upload method. Are these the pin defines? I don't know if they are. 2040, it might be in a different file. Yeah, because these are all the hardware setup things. We don't have pinouts in here. Just look it up. XIO. CDRP2040, VIDs, PIDs, build USB IDs, menu flash, frequencies, optimization. So these aren't what I'm looking for. I need a different file in here. Keywords. Keyword. No, that's not right. One of these will have it. Pico SDK system. Variants, maybe? Where's XIAO? Oh my god. Adafruit, Xerox CB, Challenger, Nation, generic, MR Seed, xiao, RP2040, pins. There we go, that's what I was looking for. Pins.h. Yeah, see, these are defined in here, D's and A's. Mosi, Miso, serial clock. Those are the wire pins. Wire 1 not pinned out. Serial what? How many? Oh, pin neopixels actually already defined. Neopixel power is another one too. Huh. Kind of cool. And then ADC resolution is defined. Okay, so we're using D's and A's in order to do our ins and outs. See, this is why you need to know where to look for this kind of stuff. It helps. Okay, so we're using D's and A's. So D6, that's fine. P1 is D7. This, I think, is where the Hagiwo code did not exactly do what we thought it would, right? It kind of defined the pins as like 1, 2, 3, 4. And while you could do that in Arduino code, that's perfectly fine. It may not have meshed with what the RP2040 core that we got defines them as. Always good to know how all the nuts and bolts are going together. P6, again, stored in the balls. P3, P26, there it is, D4. P3, D10. Did I really use that pin when I did it? Huh. P4, D9. Starting here. CV in P28 is D2. Octave input P26 A0. Oh yeah, this should be that was D2, it's A2. Audio out is P2, which is D8. I guess it's PWMing the output, so it's kind of digital. Panel LED, P7, D5. This is the only time we have to do this because we're just going to call them out by variable name when we actually use them. Potentiometer 1 pin, P27, D1, or sorry, A1. Pot number 2, P29, A3. Okay, cool. We did it. That was the excruciating part. Yeah, I should probably give these another tab, huh? Wow, why were those all completely uneven? Wait a minute. Don't see like a rogue space in there. Why? I was using tabs. Why did it decide? Weird. I don't know. Maybe the compiler is looking for elements to sort of stack up and it decides that the tab length is a little different. Okay, anyway, cool. So save that. Save that twice. Because I don't want to do that again. Okay. So yeah, we've got all our pins defined. Let's figure out how this code is working first, though. Let's go to Hagiwo's YouTube channel and check out his link for the project. I'm just finding it by searching it, right? You guys can find that. I mean, people are so lazy in chat that they won't type out Hagiwo. They'll just ask me for the link. But I guess I'll be a pushover in this case. Welcome to the chat room. Wait, was I signed out? We got new internet, by the way. I've got actual functional internet, even though my bitrate is still kind of terrible. What's my bitrate? 5,000. Huh. Kappa votes, you've got a suspicious user thing on you. Okay, so let's see. $9 VCO, Raspberry Pi. That's pretty much where we're at. So this was from a year ago. And in here, Hagiwo has his note link, and it's in Japanese, but Google Translate's doing its best, right? I don't know. Maybe it's just because you have votes in your name, but like here, this is my view. Suspicious user monitoring. Dun dun dun. Keep your ass in line, or it's grass. VCO was the most, when I conducted the survey on my YouTube channel, the Raspberry Pi Pico VCO was the most popular. However, Raspberry Pi Pico only has a 3-pin AD converter, which is a bit inconvenient to use as a VCO, which was a problem. I actually think it's fine. It keeps you kind of limited in your scope. Although, you know, having a bunch of CV inputs would probably be pretty good. It tends to make you specialize the module a bit more. In this case, I've got a nice generic module where I've got 2 signals in and 1 signal out. And that gives me a lot of possibility there. Seed xiao. AD converters 4 pins. I thought it would be possible to create a VCO with a minimum configuration. Indeed you did, and we copied you. 3U size, etc., etc. Frequency, mode, octave, push, switches the tone, CV, voltage octave out. Oh, voltage octave in, sorry. And then an audio output, 5-volt peak to peak. Cool. I don't know if ours is 5-volt peak to peak. We might have to rein that in the software, because we did I think I did a full audio output circuit on it that was copied from Mutable Instruments, by the way. We copied the best, or one of the best, I guess. One of the most open and best. Our cost is probably a little bit more than Hagiwo's. If I were to sell this module, it would not be $9, right? If I built it up and sold it, I'd probably be charging a little bit more. I don't know where that number would fall, but it would be a little bit shocking because it's a small run. So we tried programming it, didn't quite work, but we were able to run code on the RP2040. It just turns out we needed to organize our pinouts a little bit better, and in doing so, I would like to completely... Oh, that's Scampy B. Scampy B's been around for a long time, huh? Yeah, some of you guys I haven't seen in a long time because we're finally doing software again. Well, it's Scampy M1, so I think it's the same person. So this article may be helpful. The concept of interrupts is explained in detail. So we need to look at Hagiwo's source so that we can get a better idea of how this stuff is supposed to function. And we have to translate it. Damn it. That means it's going to be a little bit weird. So what are we doing here? Who is this? Let's have fun. Okay. This is a blog where former microcomputer boy introduces what he's researched and created on a whim. This is Buchaup. They got a GitHub. Buchow. Cool, cool. Lives in Tokyo. Very cool. My Python with the contributions is going to look like crap. Like, I haven't done coding in a long time. Oh man, it's bad. If I were to try to get like a coding job, they would just laugh me out the door. I'll have to update some stuff in the future and put some things in. A lot of these guys all use Mies. All right, so this time I will use a Pico's PWM for digital to analog conversion to produce sounds that can be used as sound effects in games. So our purpose is a little bit different. Pico also outputs the square wave using PWM and produces a buzzer sound like the tone function of Arduino. It's possible, however, with this method, the volume cannot be adjusted and the waveform is only a square wave. There are several ways to use PWM to produce sounds other than square waves. Generate a square wave with an inaudible high frequency, fixed value, and modulates the duty ratio with the audio signal. What? Generate a square wave that's inaudible. Modulate the duty ratio with the audio signal. The square wave itself has 2 values, 1 or 0, but by passing the square wave through a low-pass filter, that explains it. You can extract the audio signal used for modulation. Okay, so that explains the mutable instrument. I'm glad I followed that militantly. That explains the circuit hold on, let's open that up. Stream, and then that's synth. That is why we have that key thingy-majig. This is the wrong picture. That's the wrong picture. Where did our other image go? Yeah, that's the wrong one. Okay. Where did that picture go? I think maybe it's on root directory. That's a big JPEG. Tides panel, tester, blah, blah, blah. All right, yeah, there it is. RP2040. No, that's, yeah, these are our notes. So our notes are taken from mutable instruments and combined with Hagiwo's circuit in order to create our sort of mashup of things that involves actual op amps on the input and output. Mutable instrument circuits use 3 volts from an STM microcontroller. And so the STM microcontroller being just as sensitive as the RP2040, we can have designs like this that function perfectly in 3.3 volts and the range of the analog input. The Salin key bandpass filter is a particular way to organize your op amp in order to create a bandpass filter, but this is essentially doing that low pass filtration. Hagiwo has the low pass filtration coming from an actual RC filter and going into amplification and then output, and this is limiting it from 0 to 5 volts. For us, we're copying what Mutable Instruments did, which it doesn't involve 5 volts, first of all, so we don't have to worry about that. We can have native 3.3 volts for all of our electronics, and we can have the same effect. We can have the Salin bandpass filter doing that work, maybe even better, and yeah, instead of a 220 and a 10NF. It's a little bit more complicated with all the parts, probably a little bit more expensive because we have more op amps in play, but this is from like known super duper modular guru Mutable Instruments, but it is doing the same thing. It is doing the same task. I hope. Maybe I missed a detail and it's not doing the same task, but I think it's okay. Games haven't used sound generators since the 16-bit era. Used to have like a white noise track that they would use to make drums. They'd always have that cool 16-bit kind of sound to the drums. Okay, so let's go back to here. And let's go back to here. So now we know why the Salin key bandpass filter exists. And I think, you know what, I think when I was building the Mutable Instrument module on stream, somebody explained that to me, and I completely whiffed on that and did not know. There was some kind of a story that was involved, and it was like a whole like lore thing. There was like this whole story about like, I remember something, it was something about Japan, and I read it, and since I was streaming, since the cameras are on, it went in one ear, I processed it, and then like an FPGA, I just shot it out the other end without really retaining anything. So anyway, the reason why the signals used for modulation can be extracted by passing a duty ratio modulated square wave through a low pass filter is intuitively easy to understand if you think of it as controlling the brightness of an LED using PWM. The LED blinks only on and off, but it appears to be lit at a medium brightness due to the afterimage effect, which we had a professor in college, our Engineering 101 course, which is supposed to make you, this is a Canadian fellow who's supposed to make you excited about the wondrous possibilities of engineering. Look at all the things that we can do with numbers. Oh my God, oh goodness, everything is great. And so one day, the professor puts an LED in front of us and goes, "This LED is flashing at an incredible rate. Can you tell it's blinking?" And my friend and I shook our eyes and saw dot trails, and we said yes. He's like, no, you can't. And we're like, yes, we absolutely can tell that that's flashing. Like, 2 double-blind tests will be able to tell, because if you move your eyes, they flash. This is like the same exact thing that plagued early 2000s cars with taillights. They went, LEDs have like 1 billion hours of functional time to them, and they're cheap as hell. So why don't we put a ton of them on the back of the car, and then we can have brake lights. And they did that, and they went, whoa, this is way too bright. Let's pulse the LEDs, and we can dim it a little bit. And so they pulsed the LEDs, and then every car on the road gave you this weird dazzling effect where it was a trail of like marquee LEDs that were unassociated with one another. It was terrible, very distracting. But yeah, they thought that, no, you can't see that. It's like, yes, we can, because they'll move and we'll see a trail. Anyway, the principle here is this sort of after image effect of dimming an LED. You can change the frequency of that too. You can do a higher frequency and it'll get rid of that sort of dot trail that you see. That's a cool little principle there. Low pass filter corresponds to the after image effect. So essentially you're, I don't know, charging something up in order to make the frequencies. This is the method that we will use in the article. An external low pass filter is required as hardware, but this is a circuit that can be made with one capacitor and one resistor as shown below. Well, that's not what we're doing, but 100 NF and a 220. So Hagiwo has two of these in there. We have a Sallen-Key bandpass filter in play. I really hope the Sallen-Key bandpass filter does do the job that I think it's doing, because if it doesn't, we get to figure out why and how to fix that. I'll have to add a resistor and capacitor ahead of the Sallen bandpass filter, which will require a little bit of hardware modification, and I will be eating crow. But I'm hoping that this... Oh, where's that text document? Where's the... Sorry. This thing. Hopefully this is doing the job of that. I really hope so, because we're SOL if it's not. It's okay even if the capacitor and resistor values differ by about twice. The output low-pass filter can be connected to headphones or an amplifier. If you have VGA demo bass, you can use PWM output. That's some specific to their applications. Square wave used as a carrier has a frequency that cannot be heard by the human ear, so you can still hear sound even if you connect headphones or earphones directly without using a low-pass filter. Note that the piezoelectric buzzer only produces a loud noise similar to the sound of a mosquito. GP27, this is aligned with the design of the VGA demo bass if you want to use the left and right channels. Okay, so that's just specific to their hardware. Regarding the software, what I created this time is a simple synthesizer. Multiple channels of square waves, sawtooth waves, triangle waves, and noise can be output, and the frequency and volume can be set. I aimed for something that would be affordable for creating something similar to the sound effects of a Famicom, of course. It's also used in the VGA version of Block Breaker. First, I'll give an example how to use it. The calling side specifies the waveform. The calling side, so I guess the call to the function specifies the waveform, PSG type, frequency, and volume as the PSG, blah, blah, blah. As shown in the code below, the first argument is the oscillator number. You actually play it, it makes this sound. So how are they doing it? This is not a lot of code. Interesting. 0 is square, 1 is saw, 2 is, so that's PSG type. Volume is set at 0. For int, j is equal to 0, j is less than 3. So for 0 to 3, volume j, volume max over 4, float. What are we doing here? PSG frequency of j is f0. F0, we're multiplying by 1.07. We go on to the next one. So I guess they've split that into a table. You can also make multiple sounds at the same time. The example below outputs at the same time. The entire code has been uploaded to the following repository. Below is a brief description of the contents. Here we go. First, number of quantization bits and sampling rate of the audios to be output is 10 bits and 122 kilohertz. What do we use? We used 1020 something, right? Hold on. We used how many bits? How many bits? It's 6 octaves and it's 1230. So 122 becomes 1230 maybe? The conversion uses PWM basically only requires specifying the analog amount you want to output as the duty ratio of the square wave. Huh? Wait, what? Wait a second. Analog amount you want to output is the duty ratio of the square wave. I see. Weird. The number of bits used to specify the duty ratio becomes the number of quantization bits. The sampling rate is the frequency of the square wave. These cannot be determined independently. The product of number of duty ratio stages and sampling frequency becomes Pico's PWM clock. So the PWM clock inside the Pico. Standard clock is 125 megahertz, so if the number of quantization bits is 10, sampling rate is that number as dictated by the number of steps. I don't understand any of this. PWM hardware structure is shown in the diagram below. The value of the PWM counter increases every clock, and after reaching a certain specified value, GPIO outputs H. H. This is something that's lost in translation, possibly. Oh, outputs high. Okay. PWM counter increases every clock. After reaching a certain specified value, it outputs high if the counter value is smaller than the value, and low if it is larger than the value. So if it outputs high if the counter value is smaller than the value, and low if it's larger. Counters reset when the maximum value is reached. The time interval of this reset is sampling rate, and the maximum value of the counter is the maximum value of quantization. So we have a register with a number in it, right? And the number is counting +1, +1, +1, but it's not just a 1-0 kind of thing. And so when a specified number is reached, it'll go high and low and high and low, right? So those numbers are the quantizations of the or whatever, that variable, but that variable counts up, but it's a binary number, and so that binary number has limitations, and when it reaches the limitation, it wraps back around. And so I think that's what they're trying to describe here. We have a specified range of high and low, and as it counts through that, it resets and goes back to the thing again. The maximum value of the counter can be specified within range of 16 bits. If you specify 65,535, the maximum value that can be specified in 60 bits specified in 16 bits. The PWM frequency will be 125 megahertz over 65,536, which is 1907 hertz. This frequency is too low to output audio. What? In this code, the number of quantization bits is 10, so the frequency is 122.07 kilohertz. Digital amplifiers that use PWM seem to use frequencies from 250 kilohertz to 1.5 megahertz. Note the maximum value of the duty ratio does not necessarily need to be a power of 2, but in order to play audio with a predetermined quantization bit number and sampling frequency, such as 16 bits, 44.1 kilohertz, the sampling rate must be set in any case. What is that even? You will need to redo the conversion or quantization. Pico Extras has a PWM audio. It's a highly functional library, which includes functions such as sampling rate conversion and dithering using an interpolator. Whew. Next, waveform generation. Rectangular waves, sawtooth, and triangular waves. If you want to do it seriously, you should prepare a wave table with alias noise countermeasures. But since I'm not concerned with the sound quality this time, LOL, I won't do that, and I'll generate a waveform with the following definition. The horizontal axis, oh god, which one is that? Is that phi or something? The vertical axis is y. Half and one, y is equal to phi. These are, oh boy, I think these equations are in one of the versions of it. So it's a 0 increase over time and 1 corresponding. Jesus. I'm not retaining any of this information. 10 bits, 1024 values, yeah. There's noise of the waveform, but the random numbers used in the noise are generated using the RP2040's hardware random number generator. What? This is something that can generate one random bit. Rand in the standard library seems to behave strangely when used inside of an IRQ handler. So use random inside of an interrupt request. Huh. To implement the above, every time the PWM counter reaches its maximum value, generate an interrupt and specify the duty ratio of the next pulse. The interrupt handler code is as follows. All right, so this is getting more into it, huh? Clear IRQ, audio L, PWM audio R, clear IQ, go to slice number. Huh. This time is over. Okay, I'm confused. But I have a little bit more of an idea of what's going on here. Not much, though. Let's take a look at our code again. This is breaking my brain. I should have gotten a good night's sleep before this. Duty ratio. Yeah, that's pretty much where I'm at. So this is our, which one is this? This is the Arduino code. We also have a different code that I think is a little bit better written that we could potentially base this off of. Frequency calculation, analog read, pin 26 times calibration. Constrain 0 to 1225. Frequency pot map, so we're mapping a number. So that gives you two number, you give it a variable, right? And then you give it an initial range, and then you give it a from and to range, basically. It'll map one to the other. So that's from the frequency potentiometer. We're analog reading a 0 to 1024, and we're mapping it from 0 to 127. Is it from to? I forget the map function. These are nice little functions that clean up your code. Some people hate them, but those people are not fun at parties. Arduino reference, which is just Arduino CC in a couple clicks. So map, it's right in front of me. Map goes from low to high? What the? Doesn't make any sense. Wait, value from low, from high, to, yeah, low and high, from and to. Okay, there we go. So from the original range of the value to the new range of the value. So left to right. So we're mapping it to from 0 to 1023 because it's a 1024. It's just the amount of granularity that the analog read has, and we're mapping it to 0 to 127, which is an odd little range there. This is analog read 26 times a calibration. So that may be something that we need to, like, we can either make a program to do that, or we can maybe measure it with the oscilloscope. Analog read 26, etc., etc., etc. Yeah, we'll have to bump this out into some functions, huh? 256 times the oscillating frequency over 122070 times 1 plus octave switch. Jeez. All right, well, we need to grab this stuff out of the loop and turn it into the right thing. Set channel level, slice number, PWM channel A, mod 2 wavetable of K plus 511. Yeah, we're gonna have to come back to some of this stuff. Let's do the stuff that I can understand rewriting, which is the simple functions in the loop. Maybe, yeah, maybe they want it to be MIDI compatible, because maybe there's a way to there's a way to update it. Possibly being used for other circuits. So let's steal the whole loop, and let's get into what the loop's doing and rewrite some of this stuff to be the proper numbers. So first of all, we are doing the business of figuring out what octave is selected and putting that into a variable called octave_SW. But it's going from a digital read of the pin directly, huh? So if read octave, each one of these, look at this. So each one of these is coming in directly as a read, which is not a way that I would really like to do this. So I can do, we can do, let's see, a uint 8w. Is that how you do this again? I forget how I used to code. Hold on. I'm going to open up something that I coded a while ago. I don't remember how to write software. my god, which one is this? That's all 3D design. It would be in software, wouldn't it? Nope. Is there an Arduino folder? Old resources, Merc PCB, M3 SMG, hardware, H shifter. Oh, Arduino, there we go. I just want to look at some old code, just to remind myself. Takes a little while to open. Hello? There it is. Oh yeah, and I need to grab those research links and put them in the top. All right, defines, diagnostic, constant byte, UN8_T. Okay, there we go. I'm just gonna put this all the way over here. And do a rewrite of this, so this will be octave select, and then we do what are we doing for this? I'm going to UN8T, and I don't need this variable to exist, so every time we run this I'm going to be creating this new variable UN8T, and then that'll be oct state is equal to oct state, no, oct check. So we'll run an oct checker and put it into that. I could do, should I do a switch case on that? Now, there's only 3 cases on this thing though. If there's only 3 cases, I could just do 0, 1, and 2, and then I could throw the binary numbers into the things. I don't know about accessing registers directly from the Pico Pi. That's not really a necessary thing to do. It'll overcomplicate everything if I do that. But I mean, it's just like, so I could do bit sets. That would actually be the way to do it. So let's see, how am I going to do this? Well, let me find a switch case and just remind myself of what that looks like. I didn't use one in this. What a jerk. For all the complexity of all this software, it's like, I didn't do much with some of these. Open. Maybe if I look at the, I mean, if I look at the main program, it's like ridiculous. So, hey, the pedals. Boy, I should update my IDE. This is an old version. Let's see here. Debug, loop, mean bean machine. There we go. Yeah, we're putting the reads right there. You read the RX bin if the case is equal to 0. So let me see. How can I organize this? Octave state is equal to octave checker. Octave checker will run that thing, and then we'll put it into switch oct state, and then that is that case 0 is going to be oct switch is equal to 1. Actually, we could just put that into the program because it's 0, 1, and well, why is it 0, 1, and 3? What the hell? Why is it 0, 1, and 3? 0, 0, 0, 1, 1, 0. Oh, there's no 1, 1? Oh yeah, because that's the switch is switched, blank, switched. So if it's 0, 0, that's one state. Oh, but it's input pull up. So yeah, the states are, but why 3? I guess that's just the octave shift, huh? So this might be overly complicating it. 0, 1, 1, 1, 0, 1, 1, 1. Wait, no. 1, 1, 0, 1, 1, 0. 1, 3, 0. That's a strange way to organize this, but we'll copy it. It's not exactly how I'd like to do it. I'd rather do something with bits because it'll be faster. I'm actually loading it into a different... well, octave check is there just to obfuscate our checking the digital reads and stuff. I don't want the digital reads directly into the loop. I can put it to other things. I mean, if you read the register, you could get potentially... No, but the pin register... Let's look at RP2040 pin registers. RP2040 pin registers Arduino. 32-bit port registers? Jeez. That'll be a hell of a masking function. Single I/O Arduino. Each GPIO has two 32-bit registers that control the functions and status of each GPIO pin. The language, I don't want to read and write those registers. Yeah, so maybe we'll save ourselves the complexity. Well, then actually what we could do is we could just use one singular bit set here. Or no, it would be UN8T oct state is equal to bit set, and then we'll just take the analog reads as a true false for bit set. Bit set. Set to writes a 1. Actually, we want bit. Writes a bit of a variable, e.g. bool int long. Note that the float and double are not supported. Bit write, bit NB. Which bit of the number to write, starting at 0. B is the value to write. X is the numeric variable. So we could do old push switch is equal to push switch, and then octave switch, that's push switch. So here we're doing this one, and so this isn't my code. What is this? This is the other one. Hold on. I gotta keep my code windows organized so I don't end up programming a bunch of stuff into the wrong window. So we'll do bit write, and we'll split that off into that. And then we'll do UN8T, oct state, nothing, bit write, oct state, 0 is equal to bit write, and then that would be the octave switch 0, which is oct cell 1 or oct cell 2. I didn't do 0 and 1, I did 1 and 2. I don't know which is up and down. I don't know what the function of this thing is and which one up and which one down. Because you switch the switch up, nothing, down, nothing, down. So up, nothing, and then down. And that's P0 is up. P1 is all the way down. How does that correspond to the original code? All the way down, we would have digital read, pin 0. P0 being the upper switch. So upper switch is at 1, lower switch is at 0. That corresponds to this. And that one puts the octave switch at 0. This puts it at 3, and then this puts it at 1. Strange. Okay, we can replicate that, though, because we don't know what else is happening yet. This is the rewrite. Okay, all the way down here. So oct switch of 1. So we're doing bit write of our octave state. The bit is 0. For the octave switch, bit write of digital read oct. Damn it, what was it called again? Oct cell 1. The thing is, if I put them in bit order, then they're going to be, this is 1 and then this is 2. Other way around for you guys. Doing like semaphore here. Okay. So. Oh, we've already done. Wait, what am I doing here? Not bit write. Digital read of oct select 1 and that's oct state, and that's a uint8t of oct. I mean, this could be like a uint4t, but I don't know if that's supported, so we'll just use an 8-bit variable and just call it a day. Bit right of oct state of 1, read oct cell 2, like that. It's a little sloppy, but it's a, you know, hey, we're punching bits in directly so that our switch for oct state can function properly. And so it's case 0, 1, and, well, it's not going to be exactly it. So the first one would be 1, 1. So the case is 3. So that makes 3 makes our octave switch to 1. 0, 1 means that the upper, so 1, 1 is octave switch in the middle, because both of those are 1s. I'm going to put them in order. So in order, it's if it's switched up, then it is 0, 1, and our case is 3. So in which case it's 0, 1, which is going to be 1. Yeah, it's going to be 1. Then if it's in the middle, it's 3, because it's 1, 1. And the oct switch is equal to one break. And then this one is equal to 3, because it's 0, 1. 0, 1. And then if it's 1, 0, it's equal to 0. And this would be case 2, because it's binary-wise, it's making the number 2. All right, double check my logic on that. I'm putting 0 as select 1 and 1 as select 2. So if select 2 is 0, actually, I got that backwards. So 1, 0. That way you read them in order from this to this. So 1, 1 is equal to 3. Well, that one would never have changed. So in case 3, we're equal to 1. But if you have the switch of the upper one, then it's going to be 0, 1, which is equal to 1. So that's case 1. Octave switch is equal to 3. 0, 1, 3. Okay, that was confusing. Everybody with me? Nobody's with me. I've lost all 40 people watching. This could probably be done, this whole thing could probably be loaded into a function, actually, where I just have, which is actually how I should do it. Yeah, that's how I should do it. So octceller select otron. Sorry, what did you say? You go over the whole thing with me again? Select the octave. Taking this whole thing. Because basically your loop should be a forest for the trees kind of thing. Your loop should be just your plan of what happens. And you should read through the loop and be interacting with functions. It's the whole purpose of this type of coding. So basically, below PWM on wrap, we're going to have, well, I'm not going to split off different functions, but void, what did I call it again? Select the octave. Or no, read oct switches. Oct SW read. There we go. That's better, because I can call them oct switch, and I can do octave or V octave input and stuff like that. So oct SW read. Oct switch read. That's a void because it's acting on global variables. And I could state all that stuff, but I think it'll be pretty clear just reading the code. I could do it. Read octave switch as yeah, binary set global There's probably an equation to make that work, but we'll just use a switch case. It's a little bit code heavy. I mean, I could probably change the states based on the state of this variable, to be honest. We'll look into that later, but I think these numbers are going to punch directly into equations later on. So, like, rewriting this later, I would much rather this be an equation than anything else, but we'll figure that out. We'll burn that bridge when we get to it, right? There's already too many numbers in this stuff. Weird mapping, bro. I'm into it, though. Okay, so go all the way back up here, and we continue our rewrite of the basic functions of this thing. That's our octave switch. Do the same thing for this one. Mode switch read. Looks like mode is a protected thing, too. We got to be careful about that. So let's grab this code, and let's put that all the way down here. We're going to do mode, oh yeah, void, mode SW read. You know, and another way to do this would be to have it kick back the value back into the void where it's, or back into the loop where it's going to be put into the variable. So you'd have like a read switch function that would punch the variable in. We'll just do it in the globals though, I guess. So I'm actually going to put that code there, and then I'm going to copy this code. And instead we have mode and mode and mode. And instead of this, we have mode cell. Let's just check what I've actually got. You mode cells. Mode cell 1, mode cell 2. If you really wanted to get complicated, you could have both of these programs doing almost the exact same thing, except they would have different like variables defined. I can't really totally suss out how I would do that, but you would have one function that would do both of these kinds of things, because this is pretty, it's doing the same thing twice, essentially, is what I see. Whenever I see a program doing the same thing twice, I always think, like, make it into a function. That's just kind of how they train you with this stuff. Bitrate, and this would be UNT mode state. So we only make this variable when this runs. Does that like cause wear and tear on your variables? So we have FM, AM, and wave folder. If 1 and 1, which is 3, 1, if 0 and 1, then it's 0. And if 1, 0, it's 2. It's literally just the value. So we don't even need the switch in this case. So mode state is equal to mode. And then it's 0, 1, oh, 0, 0. Wait a minute. No, that wouldn't make 0. That would make 1, 1, 0, 1. Okay, so it's having a 0 in there kind of changes it. It's 1, 1 is equal to 1, 0, 1 is 0, and 1, 0 is 2. Can I map that with an equation? I can map it with the switch case, but it's sloppy. Or I can punch in, invert that, invert that. No. 1, 1 is equal to 1. Yeah, that doesn't work. 0, 1, 0. I mean, 1, 0 is 2, but 0, 1 is not equal 0, and 1, 1 does not equal 1, so that doesn't work out, unfortunately. All right, well, we'll do that anyway. So 1, 1 is equal to 1. 0, 1 is equal to 0, and then 1, 0 is equal to 2. Interestingly enough, it's the same order as last time. So anyway, that's FM. Oh no, that's AM. AM. Wave folder. And then FM. That's annoying. I think the reason for it is that it's gonna, well, actually, I don't know the reason for it. We might be able to organize it later. We might be able to turn this into just one math equation later. This is what I said about the last one. Double check my logic. Mode state position 1 and position 0. So it would read in the way that us humans read it. Mode state begins at 0. If our switch is in the up position, that means P4, which is mode select 1, is a 0. The P3 is a 1, mode select 2. So that would be 0, 1. So mode state is now 1. Case 1, mode is equal to 0, which is AM. 0, 1, 1. I got it. Wrong. Wait, 0, 1 is here. 0, 1, 3. Oh, whoops, it's 0, 1, 2. Yeah. 0, 1, 0, which is AM. Okay. I have a feeling these are just selecting stuff and we can change the numbers arbitrarily. It's just, we don't know enough of the code yet, so. Read mode switches. MDOI. Okay, that's our mode switch read. So we're coming in here, we do the push switch check, which really, I might want to bring in bounce 2 to do that, because I like how bounce 2 functions better. It keeps you from having weird behavior when you're tapping a button frustratedly. That's for later though. So we come in here, we do an octave switch read, a mode switch read, then we need to do a frequency calc. Freak calc, you freak. And then, well, do we need to do the frequency calc there? We should probably set the mode, but I guess we're doing the business of what we just found out from the switches. So bring that all the way down to a function. And this would be freak calc. That's a void. You're annoyed. I'm a void. Okay. ADC is equal to analog read 26. What the hell is 26? A0. A0 is octave in, octave volt in. Oct volt in times calib. ADC is equal to constrain ADZ0 to 1225. I mean, should I put that as a different number? Are we going to need to adjust that, or should that be fixed? So let's put settings. Define ADC constrain as 1225, and then leave a note. Let me put ADC constrain there. I only want to see zeros and ones in my code. Damn it. Cover 6 is equal to 1220 octaves. If it's 1230 or more, the operation becomes unstable. Okay, cool. All the way back down. 1020, what would the map be? Like, why are we mapping the frequency potentiometer? Okay, so pot map in, and the compiler will just do this, but pot map in 1023, define pot map out 127. Let's do, where's that? Float mod is 0. Push switches, oh yeah. Frequency 0, int slice, okay. Frequency pot limits. I don't know, maybe sometimes the numbers can go outside of that range, considering how analog inputs work. I don't know. I love this. Map, analog read 27. 27 is the frequency pot, right? Yeah. Pot 1. Maybe we'll change that to pot F. Pot F in. Just keep them as panel LED out. Nah. We'll just call it pot F, and then the other one is, I don't know what the other one is. Hold on. So this one's pot F. Zero to pot map in to pot map out. That's the frequency pot. And the oscillation frequency, so we got the frequency pot. So that's osc pot. Pot O. I could do T and P, or do pot freak. Yeah, pot freak, pot oct. Top adjust. Pot adjust. Pot freak and pot oct. Frequency pot, frequency table, ADC plus frequency, pot, frequency pot, pot freak, ADC constrain, octave in times calibration, oscillation 250, blah, 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 blah. Huh, Jesus. 1 plus octave switch. So that's where octave switch comes into play. The 0, 1, and 3 has a purpose. What does it all mean? Oh yeah, I finally got the board. Yeah, that was I think 2 streams ago. This one's the better looking of the two. Get out of the way. This is this one has 3 adjustments and only 1 switch. We are currently rewriting code for the other one, but I've had these for a little bit now. They look amazing. Curved traces. Although the silkscreen markings look a little blurry. That's just the what is it? The Seed Studio process. It looks, the smaller fonts look a little blurry, but they turned out really well. The other one is, I got black just because I've never gotten that color from Seed Studio before, and they don't look good. It's very hard to differentiate between the FR4 substrate and the copper, but for these, it turned out perfectly. It looks really good. Yellow is a color that I will use again in the near future. So yellow, red, blue, green are the functional colors for circuit boards. Black, matte black, white, I think that's it, are impossible to see where the traces are. You have to use the nature of embossing in order to get a reflection in order to see where those are. Yeah, and then I forgot a mark. Yeah, good eye. I forgot a marking on the curse text. because I added the resistor for that LED late in the game, and discovered that the resistor marking I did not pull out of the way. There's also down here, oh no, this one has it correctly. This one has an R and a C marking reversed. So that's my way of like keeping people from copying my idea. So if they do, we'll have an R and a C mixed up and their circuit will never work. These are supposed to be flipped. R8 and C15. Oh well, still able to build it. No errors so far. The only issue that I could think that might happen late in the game, the only big issue that I think might affect us is is if the, oh, that's the wrong one too. The not Schmidt, Sallen key bandpass filter does not function the same as the low pass filter that we have turning PWM frequencies into audio frequencies. High-pitched PWM that we're interrupting and turning into different notes, I guess, as they go through a bandpass filter. Somehow we're able to make waves with that, and it's possible that it doesn't work properly. We'll see. I mean, maybe that's what we saw when we ran the code before, but in which case I'll have to put some resistors and capacitors on there. So oh god, I gotta go all the way to mod view. One sec. 1 second. What in the world? How do I use this? Oh god. Hold on. I'm learning things about how Twitch works. Huh. Neighbors. I'm looking at mod view. I've never looked at that before. Oh yeah, that's right. I deleted Journey Started's message. That's funny. Smart detection. I gotta look at some mod stuff real quick. I don't even know how to use these. There's like a bar on that, and it's not letting me change it. I've never really used the mod view before, so. Okay, so a small crowd of people, nothing's really going on. And then going up on this. No, that doesn't highlight stuff. Huh, weird. Okay, so I'm gonna stop monitoring kappa votes. There we go. I felt bad because it highlighted them for, I don't know why it highlighted them though. Oh, I can look at I can do a full audit. I don't really feel like doing a full audit. Blacksmithing videos. Yeah, this is a totally perfectly fine chatter. Weird. Any particular reason you want to put them all in one sheet? Step-by-step instructions. Challenges. It's heavy. I'm hurting my neck actually. Yeah, there's literally nothing that they said that's wrong. It's so stupid. Okay, well anyway, let's go back to regular view here before my neck explodes in a bloody a bloody balloon pop. All right, back over to code. So what is going on here is they're figuring out what the frequency is and the interrupts and stuff like that in order to create this frequency using some kind of a low pass filter that I don't understand how it works, and we're going to try to implement it and get it working, and hopefully it'll go through our filters and do exactly what it was doing on the Mutable Instruments code, which is kind of a big ask, and I'm not sure if that's correct or not. Although to be fair, it is a low pass filter, and I think the Salon Key is doing the same thing. So, but I think maybe for mutables it was to get rid of, well, it was to get rid of low frequency PWM noise. We might have to put the RCs back in. I might have to do a little bit of editing here. So let's take a look at some of these. So oscillator frequency is what we're working on. We've defined frequency pot and we've defined ADC. Actually, we can do this all in one read. We can constrain analog read octave in times calib. Maybe this is cleaner actually, because we're multiplying it by a calibration number. It's a low pass, not a band pass. Oh, because I have it written as a band pass filter here, but it's a low pass filter. Well, I'm not in MS Paint, so I can't correct that right now. So I will make that mistake again in the future. I will be making that mistake again, sir. But I appreciate it. So octave in times calibration, and then we're constraining it to our ADC constraint value. That's a little off. And that is, let's see, so we get it in the calibration frequency, and then we put it into constrain. Then we define the frequency pot as something separate. We'll just block that out into a separate thing. The frequency calculation will do read calib and constrain ADC. I don't put the equals on these if I'm explaining the process of what a function is doing. Sometimes I do, but I feel like these will be a little bit better this way. So read freak pot, you freak, and map to constrained stuff. Set freak, you freak. So oscillator frequency equals the frequency table value of the ADC plus the frequency pot. Frequency table is being calculated up in the setup, and so our value is ADC, which is set by octave in constrained. Frequency pot is set there. So the frequency is ADC plus the frequency pot. Voltage to octave apply. How is that working with our circuit? Our circuit is actually mapped oppositely because of the way that the amps are working. So it's possible that I need to reverse that. The way that our inputs work is by injecting a negative 10 volt reference. So that's not what we have here. That's what we have here. Oh yeah, this one right here. So we get plus minus, it's negative 5 to 5 coming in. Negative 5 to 5 comes in. It's shifted by negative 10 so that it becomes, or it's added to negative 10. That makes it, I did this calculation before and it totally made sense to me for about 5 minutes, and then I completely lost any semblance of understanding of it. But I totally know what this does. Anyway, the point is it's 1 to 3, and then we're adding a negative 10 reference to that, which shifts it down so that it is 0 to negative 10 now, because negative 5 to 5 is full 10 volt range, right? So we're shifting that 10 volt range negatively, and then we put it through an inverting filter and make it 1/3 of 10 volts. So 3.3 volts is 1/3 of 10 volts. Hence the 33K, hence the 100K. I don't know what the 200K is doing. And this capacitor here is just to make sure that as we get to higher frequencies, it'll start damping the amplification more. So as you get to higher frequencies, it gets by your 470 picofarad capacitor and starts influencing the input in order to make it less negative. I figured it out. I actually figured it out. I am smart. SMRT. That's me. So yeah, that becomes 0 to 3.3 volt. And when it's at neutral, when nothing is connected to it, actually when nothing is connected to it, it goes to ground, which puts you at somewhere between 0 to 3.3. I guess that's somewhere around 2.5. I think it was like 2.8 something that I got when I was measuring it on the oscilloscope, but my test equipment might have been off by a little bit. But anyway, that means that we're only limited to a 0 to 3.3 volt. It can almost get to the rail, but not really. And that becomes our input signal, and then we can figure out what to do with it from there. And what we're doing here is we're taking our ADC and we're adding the value of the frequency pot to it, which is odd. And that's our oscillation frequency. But then we take the frequency over 12 to blah, 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 times 1 plus the octave switch. What is 122.070? Let's go to our reference. Xiao, please. Why do you not use the numbers that Hagiwo uses? Hagiwo is just like, lol, my code sucks. It's like, no, wait a minute, I need to know more. Hagiwo, please. .7 to 1.3. So float calib. Why is that a fixed? Well, I guess because we're coming in and we're multiplying it multiple times, but that should be fixed to save memory. Let's go to our code and make sure that's sorted out. Where's our code? So fixed float. Actually, no, define calib. Because the calibration doesn't change. And then that's 0.7 to 1.3. PWM of the 6 o'clock, if it was 125, on the seat it's 133. So is that, okay, hold on, let's get calib out of here. We're kind of redoing this as things that don't need to change, right? Mod wavetable and mod 2. Do we have, I think there's a sys clock variable that I can put in there. Maybe not. Well, these are pins. Let's see. I guess we don't need to write it for that. I can just put in define sys clock. Is that's not reserved? Okay. And then that would be question mark. So let's do I guess you can lower it to 125. So PWM frequency. Oh wait, so freak clock or yeah. PWM frequency set as if blah 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 for calcs. That's a bit of a long description. It should be a little bit more terse than that, but So lots and lots of comments because I'm very dumb and I forget things. Should I just lower it or should I put that in as that frequency? Do you think I should put it in there? Let's take that number and I'll put in 129,883. And then over here, I can put was this number. Was it 125? What was it again? Yeah, 125. Okay, I'm glad you, Bengisimo, like, damn, you are right on the money with this stuff. I thank you, thank you, thank you. Keeping me in check. ADC constant, 1225. Yeah, okay, so we're splitting that up, huh? That one changes. AM modulation rate, float. AM mod is equal to 1. Float frequency is equal to 0. Slice number, that one changes. Oscillation frequency, push switch changes. Those are bools. Float mod is equal to 0. Wavetable. Straight, first modulation wavetable, second modulation wavetable. ADC frequency pod. Octave switch. Mode is reserved. So I'm going to do mode select. We're going to call that mode cell instead of mode. So that changes up here. All right. So in our frequency calculation, we have our calibration values applied to the analog read of the octave per volt in. What's refactor? You're talking to a caveman. I have no idea what you're talking about. Octave in times calibration. So we get it into our calibration, calibrated range. Then we constrain it to a fixed number of values just in case, I don't know, some spurious reading happens. Read the frequency pot, you freak, map to constant constrained stuff. Oh, well, so I use a very rudimentary, I use the Arduino IDE. I'm using an old version. I should probably update my version in order to be more relatable to the people who are learning Arduino and not the people who know how to use some kind of a mutant IDE that was developed by the least social person on the entire planet in order to allow coders to sit there and tap keys and have 10,000 things jumping up. No, I want it to be instantly relatable to the people who use these tools. So I use these tools. I don't use anything more complicated than that. Read the frequency pot, you freak. Okay, so freak pot is equal to the map of analog read of the pot frequency from 0 to the pot map input range to 0 to the pot map output range. So that just maps big number range to small number range and outputs it. It just means that like every other value is gone. You get a little bit less granularity. So set the frequency, freak. So we take the oscillator frequency is equal to the frequency table value at a location, which is equal to the ADC added to the frequency pot. And when it wraps around, it goes into that wraparound function. And we don't need this here. So then what do we do? So we've got our frequency table. So get value at freak table. And then we're actually creating, and maybe this shouldn't be done here. Maybe this should actually be done somewhere else. That seems like it might stand to reason. What we're doing is we are taking we're setting that frequency based on our value read at the our table value read, which is oscillating frequency right now. So the table value read over, I don't like all this dipping into the same variable multiple times. Because then your variable names don't tell you what's going on. Value. What are we actually calculating? It's 256 times table value over clock times 1 plus octave. And that's somewhere, well, maybe he mentions it. No, he does not. No, he does not. He does not mention it anywhere. Maybe in his previous iteration of this code, he might actually. Eliminate errors in the voltage dividing resistance of the voltage per errors in the voltage dividing resistance of the volt per octave circuit. Calibrate by adjusting the calibrate value. Article about a synthesizer using Raspberry Pi Pico uses source code as reference. Although I could not understand 90% of what was written based on my knowledge, I was able to learn the concept of interrupt processing. Source code is also available at the link below. Thank you. Yeah, man, it's cool. Article is helpful. The concept of interrupt explained in detail, which is what this fella's doing. So let's see, where are some of these equations here? Quantization bits. We read this, but I still don't understand it. PWM clock. Sampling frequency becomes the Pico's PWM clock. The standard clock is 125, so if the number of quantization bits is 10, you have 1024 steps. The sampling rate is big number over 1024. Yeah, it all plays into this stuff that I don't really understand. $250. I think that's what we're looking at right now. We're looking at this stuff, these math things that are going on. And we've got 256. That's the wrong code, sorry. Isn't it taking input CV frequency and octave switch and setting oscillation frequency? Yeah, that's what I suspect is going on here. And I'm wondering if I can rewrite this in any way. Because what we're doing is, and this is kind of a confusing way of doing it. I'm wondering if I can take it and I can pull it out to its component parts and then put it back together as something that makes a little bit more sense. Because we need a value of the ADC and the frequency pot are looking at the frequency table that we generated at the beginning. And then that is being taken and multiplied by 256, or we're dividing it by the clock and the 1 per octave in order to get what? That's our something something quantization something something. Oh, and the 0 to 127 is to make it half of this range. Does that stand to reason? Our pot map in and out is from 1024, which is the ADC, but then we're limiting it to 127. Our analog read of the octave in 1225, 6 by 1220 octaves. I'm very confused, but I'm starting to get there. I mean, like, it would almost stand to reason that we would just make it into one giant equation. And for some reason, it's 1 plus octave. Oh, because we're multiplying it. So if the octave switch is 0, then we get to multiply by 1. 12270 being the clock value. Did I already make a variable for that? Oh. Wait, PWM freak is 129. Oh yeah, that's a new number. Right. So PWM freak I need to put all the way down here. PWM freak. Yeah, this is a copy of code, and somebody who understands it about as deeply as I do took the code and copied it over. And so we're looking at the result of that. Maybe I need to look at the original code in order to get an idea of what's going on. Because it's just a reorganization of a reorganization, so things are crazy. 256, is there like a constant that I could put in there or something? Yeah, the question is what's happening here? We're getting a ratio of whatever is in the table thing, which divided by frequency times 1 plus octave. So frequency times 1, 2, 3, multiplying that number and getting it into the next octave. That's how 1 volt per octave works. And we're multiplying it for some reason by 256. I thought this would be a little simpler, but I guess we're jumping straight into the deep end. We're not 256 megahertz, so that's not what we're looking at. Control F256, maybe we can find this number in here. No, we can't, of course not. What does Hagiwo say about the number 256? 256 samples. The waveform is stored in a wavetable, and the audio output is interrupted by the wavetable at regular intervals. And reading the wavetable's 10-bit, 256 samples. Huh? The waveform is stored in a wavetable, and the audio is output by interrupting the wavetable at regular intervals and reading the wavetable. Wavetable's 10-bit. I don't know why we're not generating this wavetable outside of the code. We're generating the wavetable in the setup portion of the code, which means every time this thing starts up, it has to make a new wavetable. But none of those are changing. So having a fixed wavetable that's calculated linearly in the defines might be a better idea. I guess maybe I should just get the code working first. That's probably the way of things. $10-bit wavetable. So fixed, we've got define WT reso, which is equal to 256. And that is 10-bit 256 samples. The wavetable changes. Where does it change? Because remember what we did originally on this code, it had a fixed table that it was referencing in order to create the big wavetable. This is the rewrite. Why is this here? Oh. Mode switch, frequency calc. Oh, then the parameter set. Okay, so that's... What the hell? Oh, this is from the mod input. Right, okay, we'll get to that in a second. Oh, the wavetable's changed, but the frequency table. Oh. This one is fixed. It just seems like we should be making this one like ahead of time, because we come down here and I do table set, which creates that table one time. We haven't gotten to any of this stuff. I'm doing the easier stuff first. This function right here seems like it could be done elsewise. Also, all of these numbers, we need to figure out where they're coming from. All these numbers in here. Too many numbers in this code. All right, we'll get back to what we were doing though. We were rewriting some of these functions. We didn't really figure out what this specifically is doing. We can hopefully get a sense of it later. That was wavetable resolution times oscillator frequency over PWM frequency. Oscillator frequency is set as frequency table ADC, the frequency table value at the location ADC plus frequency pot, which ADC goes from a pretty big value and the frequency pot goes for a pretty small value, so I don't know what's going on in there. I don't know what's happening. There's some weird magic happening in there. And then I guess I need to force the order of operations of the math. I don't like leaving things without a lot of parentheses around it, because then you don't know what's happening when. And microcontrollers can sometimes do weird things. How's it oscillating? How are you vibing? Interrupted. That's, I guess, the scheme here. Let's see here. All right, hold on. I got to mute for 1 second. Close the window. There are dogs outside, so you might see, well, you'll only see a shadow, but the dogs might go by that window. I had to close it because people are talking out there, so. Let's see, where are we going? I'm going to, no, we're on the right page. So, all right. Wasn't octave switch multiplying before? Hold on, let's take a look. All right. No. 1 plus octave switch. And then octave switch is defined here. It's set by just a weird, it's set in a very weird way. And then it's added. I guess you could do octave down if you wanted to subtract. Sorry, trying to get my windows again. There we go. I didn't change it. .256 times os frequency, and then the frequency times 1 plus octave switch. That's what I have here. Just both sides of the parentheses. Although PEMDAS being all that it is, it might be 256 multiplied by the rest of everything else. So it could be that times everybody else. How is the microcontroller going to evaluate this stuff? 256 times the middle part times this, like a dimensional analysis thing. Mathematically, I would be evaluating it differently. So is it 3 parameters that are being multiplied out? Like that. Because, yeah, I'm always careful to do the parentheses so that I can define that stuff properly, because this leaves it kind of open to interpretation of what exactly is the denominator. And I guess maybe they would have coded it the same way. So it is, in fact, 3 separate. 256 times this, whatever that ratio is, times 1, 0, or 3, or whatever. 1, 4, or whatever, whatever that is. Yeah, everybody's talking about Pi Day today. The day to bake a pie and put the pie symbol on top of the pie that you bake. Oscillate. So the oscillation, the determined oscillation frequency over the PWM frequency. So the ratio of those two. Multiply that by the octave. Multiply that by 256, which is the resolution of the wavetable. Does that work? So it'd be table reso times ratio of the ADC frequency, ADC, sorry, the setting, oh my god, inputs times the octave setting. Table resolution times ratio of inputs times octave setting. You're basically calculating the step size to get to the next sample in the wavetable. I'm going to write that like right here because one day I'll understand. I put too many eyes in there because that's how I say it in my head. Wait. And Gizmo. Save that. Hit Control S. Hit Control S compulsively. So yeah, that's part of what that, uh-oh. No, wait, no, we're fine. Okay, there we go. Part of what that article was trying to teach me that I completely glossed over. How's it going, Mahalo? We're working on that VCO and I'm trying to rewrite Hagiwo's code. But we barely understand how it works, and I think Hagiwo barely understood how it works too. It's because we're referencing what he referenced, which is a perfectly good article. It's Bu Xiao Pico PWM sound. Here's this reference. And then if you want to look at any of the Hagiwo stuff, here's all the Hagiwo stuff. And my rewrite, I don't know, I'm working on it. But we're making it more look more like Arduino code and function more like Arduino code, and that way maybe we'll understand what it's doing. It seems like what it's doing is it takes an output of a PWM frequency and it uses interrupts in order to do something with it. It manipulates it into making it fill up or go through a filter in order to sound like audible frequencies. Let's get back to the main thing, because that got into a little bit of the fundamentals about how this thing works, and I'm more interested in making the functional blocks work correctly, and then later we can look at microcontroller tricks in order to try to make it kind of flow a little bit more easily. There's some weird tricks that you can do with, like, well, I don't know. I mean, maybe you took direct control for a lot of this stuff. So we just did frequency calculation, which was a little bit of a weird thing. Now we do mod parameter set. Actually, I think that's in the other code, isn't it? Up here. Mod parameter set. Set mode. We'll go down to the bottom here. Give ourselves a little bit of space. Void mode set. Okay, so mode set. Mode set sets the mode. What do you freaking people want from me? Mode set. If mode is equal to 0, fold FM or AM. Okay. Constrain analog read. Oy, oy, oy. What in the hell is happening here? So mode is a number. And when I do numbers, when numbers happen, I like to use a switch case for that kind of thing. Oh, mod for modulation. Wait a second. Yeah, right. Mode is mode. Mod is mod. Totally easy to interpret. Oh, great. What is all this crap? So if mode mod. All right, so mod, I'm gonna do modulation then. Maybe modu set. Modu set. Wait, mode set was already. No. No, wait, mode switch read. So this would be modu set. Modu set. Modu set. What are we doing here? Analog read of 29 and 28. 28 CV, 29 is the pot. What, huh? Wait. Oh, if mode is equal to 0, 1, and 2. Why are we doing this here? Because we've already taken our values in from that. That's a strange thing to do. We shouldn't be reading these anywhere else except for, we should be reading these in one location. So we're somehow setting them, control voltage and pot, we're reading them there. Huh? What? Fold FM and AM, 0, 1, and 2. That's just a code based on the position of the switch. 0, 1, and 2. Case is equal to 1, case is equal to 3, case is equal to 2. Yeah. I mean, really, you could do this. We could do this in the actual code. Hold on a sec. Let me just void loop 1 modulation. What the hell? This code is killing me. Mode is equal to 0. Else if mode is equal to 1. Else if mode is equal to 2. That's where we set the table down there. Like all this stuff, I'm thinking we could pack into one function because we've already got our mode being set and it doesn't need to actually do anything else. Except we'll need, what is this? Constrain analog read of 29 plus 28 from 0 to 1023. Multiplying it by a weird number, and then we're taking 90% of that number. 0.0036. What the fuck? Like, what? What? Huh? Like, yeah, great comment. 28 is CV, 29 is pot. That's, wow, what a great comment. What the hell are we doing right here? What is this? Help? Huh. So far, the logic in this program has been just like basic logic stuff. But now everything goes crazy. And I'm constantly thinking about how to simplify this. But what we're doing is we're getting a mod. So what happens to mod? Mod goes into mod times wavetable 1 is equal to wavetable, 256 values. And that's the modulation that's happening. What the fuck? Like, why is this happening in so many places? Because depending on what modulation, what mode we're in, the modulation changes values, changes the scheme. Okay, this is turning it into a, I guess, I don't know what the fold exactly is. This is pertaining to the calculations on Bochow. Reaches 1, then returns to 0. The value of y corresponding to phi is converted into a PWM duty ratio output. Phi increases with the period of the sampling frequency, but the increment is determined by the frequency of the sound you want to play. The step in the figure below is an increment, but if you make the step smaller, you'll get a lower frequency sound, and if you make it bigger, you get a higher frequency. Sound frequency, sampling frequency. Sound frequency over sampling frequency. Is that what we're looking at here? Wait. In the frequency set. Sound frequency over sampling frequency. Frequency table, frequency, jeez. Okay, that is exactly, yeah, that's what Gizmo was saying right here. That's this. So we're determining that step. Which still doesn't tell me where these weird multiplies are coming from. Increase the period of sampling. Play. Step of the figure below is an increment, but if you make the step smaller, you get a lower frequency. Okay, so sawtooth and triangle waves. 0.5 to 0, y is equal to phi, 2 phi, 2 times 1 minus phi. We got like 0.036 and 0.9. And this one is directly divided for FM. For AM, it's just simply the constraint. Oh, it's 1023 minus. What the I have a 1023 up here already. Nope. What? Okay, so in this equation, what is the function of 1023? 1023 would be the maximum PWM, right? Arduino PWM reference table. Let's reference Arduino PWM real quick. I just want to look at that to make sure that I'm saying the right thing. So we go to Arduino reference, arduino.cc/reference, and we look at PWM. Cool. Analog write. Oh, analog write resolution probably returns. Oh boy. So Seed Studio Xiao. It's going to vary from hardware to hardware. PWM wave to a pin can be used to light an LED, varying brightness, various speeds, analog write, digital write, digital write. These pins are officially supported. Syntax, analog, pin value, Arduino pin allowed. The duty cycle between 0 and 255. Oh, really? Does that, I think that changes. I don't think it's 0. Is it 0 to 255 in the xiao? Well, we're analog reading, and constraining, but then eventually we're going to write that. But at 1024 minus the constrained read to 1023. So constraining it 0 to 1023. Analog read. Okay, yeah. Oh, right. Okay, I got confused. We're not writing. We're reading. Which, depending on your hardware, should typically be 0 to 1024. Between readings of 5 over 1024 units. So analog max. D setup. Oh, void. All right, so define a read max a read max analog in. There we go. Anywhere I see a 1024, I'm putting a read max a in. And it's only in one spot. Max it in. And to be honest, this is a perfect example of where you want to use a variable. So we're probably int range. We'll do Arduino stupid. Int, and this would be the, I guess, read value is equal to value analog read 29 and 28. That's so weird. Pot octave and CV in. Okay, so rid of this comment. And then switch mode case 0. Gonna rewrite it. We'll figure out what it does later. I ran into a wall. Oops. It's like I feel like I could do more in these case things. Right? Because there's a lot more calculation that's involved in this. Brack. Oh yeah, you're right. I would have gotten there eventually. I wonder if you could scrub that better. Mod is a global? Float. Mod is equal to 0. Okay. Yeah, it's odd, the stuff that we're doing. We still haven't even gotten close to on PWM wrap, and I don't know what's happening there. That was just a function that existed. That might be part of the PWM library that they're using. Yeah. Oh, we got to set up our proper interfacing with the realm of meat. Okay, so that would be modu set, even though that's really mode set. On PWM wrap is where a new audio sample is set. I wonder when we use that. Push switch is equal to digital read 6. Really? Handle switch. That could be turned into like the bounce 2 library. We do with bounce. And then handle switch all the way down. Well, let's put it up top so we can find it again. Frequency calc. Give these a little room to breathe. I don't mind a little bit of white space as long as it's controlled. Void, handle, switch. Handle switch, push switch right there. Take that whole thing. Such a weird way to do stuff in this program. We finally have the loop in the way that I like it, which is where it's just a bunch of functions that explain the step that's being performed. This is happening now, this is happening now, this is happening now. That's how it should be, as God intended. As God as my witness. Huh? So, uint, well now, bool. Why are they, oh, they're looking at previous value there? Old push switch is equal to the current value of the push switch. That negates any pushing of the switch that might occur. But I guess they have it set it to the old value. That's weird. If push switch is equal to 0 and old push switch is equal to 1, on waveform plus plus changes the waveform. If waveform is over 7, waveform is equal to 0. If mode is equal to 0 or mode is equal to 2, set the table again. Table set. Huh. Well, they have an underscore on their table set. Where's table set in here? Oh my God, what the hell is this? Table set. Table set. Oh God, it's this thing. This is This is disgusting. Look at this thing. Oh God, this function. Let's do a bounce 2. Let's do it. I'm not going to be able to sleep at night unless I do a bounce 2 in here. So examples, bounce 2. Bounce 2 has gotten fairly old, but it's the way I like to keep stuff from running into, like keep your button from pressing multiple times if you accidentally like tap it too lightly. So bounce 2 is fairly simple to use. And what I'll do, I'm basically copying this code, and we'll put it into the push switch handler. Up here, include bounce, capital bounce, 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 bounce on you boy, bounce 2.h, and then we do in the defines, we already have the button pin, we already have an LED pin, although we're not doing the LED example exactly, but after this, we initiate the bouncer. Init bounce. So I'll just do inits. This is, no, what are you doing? Get out of here. I'm gonna move it over. I'll just copy it. Bounce, debouncer is equal to bounce. There's a lot of bouncing going on. Void setup, pin mode, button pin, button pull up, and then we attach the debouncer. Set pins, PWM settings, timers and tables. Oops. Yeah, all this stuff is, we haven't gone through this yet. Debounce. Debouncer attach to BTN. Interval, make it 10. Actually, wait, bounce interval in milliseconds. That'll go into settings. Define B timer. B time is equal to 10 seconds debounce button. Give that some room. I already forgot the name of the variable. B time. Don't need that there. That's a debouncer. So on our loop, we do debouncer.update. And then when we handle the button, handle switch, mode switch read, frequency count, mod use set. What am I calling it? What did I call this? Table set, PWM, handle switch. Oh, handle the button, PTN. Handle button. Don't need this comment anymore. Ha ha ha. Inits, didn't I do that? I think I did. This is an old comment. So handle button is where mod use set. Handle button. Switch the mode. Oh, small I? I'm not capitalizing. Who cares about that? Who cares about capitalization? So we have to read the logic of this. So I'm just going to move this down, and then we'll do value is equal to debouncer.read, right? So we have switch is equal to debouncer read, and that would be actually what's going on all the way up here, because push switch does not need to go outside of this. Yeah, push switch and old push switch. It's like we'll do push SW. And then down here, I'll have bool new SW is equal to debouncer.read. And then this is not necessary. This is not necessary. That's not necessary. So it's if mode is equal to 0 or 2, table set. If waveform is greater than 7, waveform is equal to 0. If push switch and old, push switch is on, waveform plus plus. That's a weird way of doing this. Okay, so pretty much take this and put it here. So if the new switch does not equal the push switch value from before, well, that's going to double tap. Value is equal to low, high, else LED pin low. So we want on release. And I think there might be an on release for this. Examples, bounce to on change, I guess. You got to be sure because these things would make it so that you'd be going every other mode. You don't want that to happen. Well, the code that we were looking at, I think when you have the switch pressed down, it'll open up. Yeah, debouncer fell. That's easy enough. Debouncer update. I don't even need that. Yeah, we don't need any of this. It's if debouncer.fell. So I don't even need to store this. It updates, and if debouncer fell, debouncer fell. Let me look at the code real quick. Yeah, debouncer fell, then we just do whatever's here. Waveform plus plus. Waveform is greater than 7. Waveform is equal to 0. And this should probably be another define. Num waveforms. Well, 8. And then this would be, where are we? Num waveforms minus 1. Waveforms equal to 0. Waveform plus plus. I don't need to say that there. Bouncer fell. Waveform plus plus. Give that a little space to breathe. These are one line, so I'm going to make them into one lines. Make that wraparound code a little tighter. If the debounce falls, waveform plus plus. If the waveform is greater than number of waveforms minus 1, waveform is equal to 0. If mode is equal to 0 or 2, set the table. And then my dog starts barking. There's your whir. This could be simplified. There's a lot of stuff in here that I think can be simplified. Why is it plus 511? There's so many numbers that I don't know what they're doing. Or if you gave me just the benefit of the doubt by at least like breaking them out into settings, like, God. It'd be so much easier than this. What this will allow me to do, though, is if I can break out these modes and make them make sense, I can then have some kind of a logical LED thing happen. Like on debouncer up, I can have the LED like blink or something like that. Actually, wait, what is that one then? Debouncer fell. What are my other debouncer stuff that I can do? Probably be better to just look at the debouncer code. The .h or whatever. Duration, maybe? Takes forever for this to open up. I should probably wipe all of my Arduino stuff and come back at it from a new perspective, because there's a lot of mess that's kind of gotten into my microcontroller stuff. That's only if debouncer fell. Okay. Yeah, let's open up the debouncer code and see what we can get here. So before we had a window that was all the way in. I guess I closed it. I must have closed it. So app data. Local. Arduino 15. Oh no, you know what? I probably need documents, and then Arduino, and then libraries. Well, these are the libraries. Libraries, and bounce 2. There it is. And then we need JSON properties keywords. I don't know if that, well, that's not correct, is it? No. Keyword is equal to keyword is equal to keyword, keyword, keyword. Not quite right. Source bounce.h. There we go. Bounce. Bounce. Attach. Interval. Update. Read. Fell and rose. Rising edge. Falling edge. Pin interval. Duration. State, pin, state, blah, 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 change state. Okay. So we have fell, rose, rising edge, falling edge, interval, and I guess that's it. But I guess what I can do is I can read that separately, and if it's high, I set the LED to whatever it is. So what I can do is do like an LED handler. Because that's like, this is like 101 microcontroller stuff, is I can just do like where are we? We're down here. Debouncer update, and I can handle LED, and that'll just light up when you press the button, just to show you that you've pressed the button. So I'll do all the way up here, we'll do handle LED at the beginning of my functions. And over here, I'll just do below PWM wrap, we can just do void handle LED. And what that'll do is it'll look at digital, or no, it'll actually digital write LED pin, digital read, what was it called? BTN button. So that just button down, LED on. It's just a doubling of the LED until I can come up with something more complicated. It just doesn't need to be anything more than this. Button on, LED on. Oh wait, no, the opposite. Not digital read button. Because of the input pull up. What up, Keeper of Maps? How you doing? How it going? Keeper of Maps is subbing for 50 months on a 50-month streak. Hey, thank you so much, Keeper of Maps. We're trying to figure out what somebody else's code does, and it's tough because there's some things that I really would wish were commented that aren't. We've got some numbers in here that I'm a little bit reticent about, and I don't really know what's going on here. There's some PWM stuff that's happening too that I need to look at, but we're getting through it. I mean, this is just like the nuts and bolts of making a new program, and we're making sure to stick to the philosophy of the main loop should be human readable to be a bunch of functions that do the main things that this program does, which in my case is typically get the stuff from the outside world, do the calculations, output the stuff. I usually have it pretty structured like that. So yeah, get stuff from meat space. Calculate stuff. Output stuff. That's generally how I organize these kinds of things. Work has been crazy, so I haven't caught many of your streams. How fucking dare you? I cannot believe you've done this to me. That's fine. I'm totally happy with that. Don't worry about it. Actually, well, there's a little bit of outputting going on at the same time. That's totally fine. Yes, so a channel or a page where I can learn to program. I have nothing of the sort, but I know that people for years have been climbing over each other to try to become that resource for people. Tutorials you'll find everywhere. And the question is, which one speaks to you? Which one gets you learning? Because I don't know. I'll take it up with management on my next performance review. I'm sure they'll be thrilled to learn all about. Oh God, there's so much stuff going on here. I don't know what the hell this thing is doing. 0 to all the values I++, frequency table of I is equal to F0, frequency 0 times power 2, but F0 is never changed, is it? F0 is set. Base oscillation, so that should really be fixed. Let's just check. F0 is not set there, and that's the only place it's used. Yeah, so it's like these kinds of things. Instead, we define it in the settings. We don't even need it as an int. We just F0 is equal to 35. That's our base oscillator frequency. Oh wait, we don't need semicolons on this. We don't need equal signs either. And it probably should be all caps. So that should be F0, big F. And then this becomes big F. Big F. I'll probably tab that and make it look better later, but there we go. That's looking a little better. Oh yeah, calib. Where are you? Oh. There we go. Save that. Those mini mills look great. I must admit, starting to think about getting one. Yeah, super distracted looking at K-trucks and mini mills. K-trucks are just coming to America, aren't they? Because they're 25 years old. Is that what's going on? Because I've on multiple occasions had K cars, not the Chevy, or is that Chevy or is that Dodge? The K-frame car. We're not talking about that. We're talking KEI. The K cars. My friends have been like, you should get this one. Like a little cute little van with a flatbed on the back. Those things are awesome. As are mini mills. That'd be kind of a funny car for me to drive around. Ah, that's right. There is a distributor in New Jersey. That makes more sense. I've been seeing them on Bring a Trailer with more regularity than I'm comfortable with. So what we've been doing is we've been like rewriting all of this crap. And the problem is we don't know a lot about what the code is doing in the first place. We're sort of learning as we go, but there's a lot of strange things that are afoot at the Circle K. This is all in service of getting this voltage controlled oscillator working and also having an understanding of how the code is running within it so that we can make more stuff with this. This is not just a voltage controlled oscillator. This is an RP2040 with multiple inputs and a single output. And so we can use this to create other types of modules. We can make samplers. We can make all sorts of other weird stuff with this. The only thing that concerns me is the methodology of making a PWM signal into an actual audible wave is very strange. It's a very strange thing, because you put it through a low pass filter, and it's a something or other key low pass filter, and that turns your PWMs into audio wavies. That's all I can really, I can't explain it properly. A Salin key low pass filter, not a band pass filter. It's a Salin key low pass filter. But apparently if you hit high frequency PWMs and you like interrupt them in the right way, it'll do that. Don't need this. This is okay, so from my end, from my perspective, this is like very satisfying stuff to do, because I'm turning code that was otherwise like very difficult to understand into my sort of regimented organization of code. And it's, you know, I get to get in there and I get to, oh, I know how to make this a little cleaner and this a little cleaner. Sort of iteratively go through and clean up somebody else's code base. When it comes time to run this, it's not going to run. It's going to be like a huge struggle. But we'll spend a couple days doing this, and then we'll have good code on the outset. And hopefully that'll lead to bigger and better things. But like visually, you guys watching the stream, it's probably not as followable and not as satisfying as it is for me to just go through and, oh yes, I can move that there and put that there. I'm so smart. Like, so I can share sources and everything too in the end. But yeah, it's just one of those things, one of those little engineering things. Make sure that that's in focus. Anything else going on? Did I miss anything? We got follows. We got Keeper of Maps for 50 months. All the way going back to a shout out 2 days ago from Flatulent Gonad. All right, cool. So the read value from analog is 0 to 1024, which is a uint 16T. Wait. 8T values. Oh god, I can't type on this mini keyboard. That's from 255. 16, I think is that 1024? That's 65,535. Uint 12? Is that even a thing? Uint 16 to Uint 12. I think it's 8 and 16, isn't it? Like, I was thinking you could just limit the value with that, but I guess we can make it a uint 16t instead of an int. Wait, int is 16, isn't it? Yeah, so 0 to 1024, I don't know what structure limits that, so I guess we're going to continue to use constrain, I suppose. So those are our two analog reads, 0 to 1024, added together, and then we're max analog input is 1023. Then our mode. See, why are we doing... Our mode is set elsewhere, but I guess once we get that read value, then we put it into this variable mod. And this does the opposite. This just reverses it. Huh. That divides it by 8, even though, so can FM never get quite to the right number? And then fold does some weird bullshit with numbers that I don't understand. I don't understand why these are here. PEMDAS, right? So we're taking a fraction of the number and then we're adding 0.9 to it? Strange. Okay, so yeah, it's like I barely understand what we're doing here. Lowercase oct switch is set in a different function. Mode select 0, 1, and 2. Oh, this should be mode cell. we got to get into one of the weirder parts of the program, and that's this stuff, the table set. I don't know what it's doing. This is a big weird thing. All right, let's start. Listen, you know, you guys got to let me run into the bumpers in this game of Galactic Bumper Pool. Fills the wavetable with a waveform. We got to make this a little bit nicer. Saw, sine, square, triangle. So we're going to bump these out into functions. Like make saw, make sine, make square. So mode is equal to 0, wave fold. I gotta look at how these are functioning, because it seems like we could probably make a lot of these into different functions. What are you doing? I need space to think. 0 to 256i plus plus, so 256 value wavetable, and then it uses a particular function in order to do that. So let me think about how I can organize this a little bit better. Let's get rid of all this. Start at the top. So there's two main pieces of this function, table set. Let's go back over to here and let's make a void table set. In my fashion, we could possibly have a parameter pass into this. So void table set, switch waveform we're starting, well, if mode is equal to 0, mode is equal to 0, mode is equal to 2, that's it? Oh. Mode is equal to 0 and 2. We're missing some, we're missing 1. I guess it goes with whatever was there before. So switch mode cell, mode cell case is equal to 0, break case is equal to 1, break. 0 and 1, 2 cases. And then we have the waveform check, but we have 2 sets of waveform checks. Wavetable of I times 4 minus 512, wavetable of I sine 2m pi 511. Mode is equal to 2. Waveform number of 0 to 7. There's 7 modes for each mode, and they're all different things. They all do different stuff, is what I'm working on right now. Weird. How do we reconcile that? Yes, thank you. I know this. I know this. What I'm doing right now is I'm cross-comparing what the different, if you're in mode 0, 1, or 2, what is it doing for wavetable or wavefold 0 to 7, right? And it turns out they're doing completely separate things to the wave. I'm just making sure that they're different because that means I have a lot of programming to do. This looks familiar. What the? Hold on a second. So, what was this one? That says saw, but it's exactly the same as sine. I don't know if that one below is actually saw. Because those are all the same numbers, which means that we only need one mode for that. Let's check a different one, huh? Let's do oct saw. It could be that the other saw has a problem with it. Hold on. If mode is equal to waveform saw, that one has the sine in there. FM1 has that one. It looks like it doesn't have the same ones. Sine 2m pi, blah, 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 511. This one is FM2. That's more my speed. This is what I was looking for. So what's happening with this original saw, because technically this is sine, this is saw, wavetable I times 4 for case 0. Saw, and then FM. Mode is equal to 2, AM, saw, 511. Yeah, it's nowhere else in the code. I did something similar with the Hellraiser movies where I watched them all in a row, and by the middle of that watch through, you start to lose your mind because the Hellraiser movies begin to become just Hollywood treatment scripts of cop shows that they rewrote to have Cenobites in. So you're watching like this really shitty cop movie, and all of a sudden there's somebody there in full fetish gear, and it's like what happened here? The first 3 Saw movies are okay. The first one is brilliant, and then they're kind of okay from there. Not Saw, sorry, Hellraiser. I was talking about Hellraiser. But I've never done it with the Saw movies because I don't really care about those. I don't know. Yeah, the Cenobites sounds a lot like Cinnabons, yes. The latest one was pretty good. I'm not that big into horror. I'm not a huge horror fan. A horror fan. Wait, is this... Wait a second. Oh, you've got a for loop in there. I see. These equations get longer and longer, too. They start to become a little bit unruly. But I think I can get away with the same cases for everything. I just don't know what happened here. This has case, what, 0 through 7. This has case 0 through 7. And here's some of the equations look like they've been cleaned up a little bit. Hellraiser watch party. I don't want to do that again, though. That's the problem. I don't want to subject myself to that kind of mental torture. It was awful. It was terrible. Mode is equal to 0. Mode is equal to 2. There's no mode is equal to 1, which is a little weird. What the fuck? Hold on a second. There's a lot of stuff going on here. So that's modulation. What are we doing here? Mode is equal to 0. Mode is equal to 1. Mode is equal to 2. I see. So that's our 0, 1, 2. And then table set has mode 0, mode 2. Okay. Oh my god. What do we do here? This needs a lot of reorganization, it seems. That's our switch. So now we're down here and we're looking at a couple different big functions. I know it almost garners a flowchart. It does. Because this is like unorganized and not even in our language the code was performed. And I guess the Japanese code differently. They don't code the same way we do. I mean, for a large part, this has been pretty readable and we've been able to figure this out. But like this kind of crap right here, it's like this needs a different. This should be in a function, right? There's plenty. We were looking at what is it? The explanations. A little bit of a yaya in there. We got a me as a picture. Not a lot, but just a little bit. All right, so let's see here. I watched Morbius once and it wasn't bad funny. It wasn't worth, like some movies are worth watching that are absolutely hatefully bad, and the difference really is the amount of like confidence and heart that goes into the movie. The movie has a lot of heart going into it. If that director thought that they were, you know, the next coming of the Lord and Savior, and that their movie was going to benefit the rest of us by having it out there, and their movie is just them bragging about themselves, there's a certain amount of like heart that you can get in that failure for them to understand the basic principles of movie making, right? Morbius, they very much understood how to make a movie. It was a very bad movie, and so it became, and it was a soulless corporate venture, and you could see that, and Jared Leto is difficult to watch. So it was not a good movie, and it was not fun to watch. Something where like they could barely afford a camcorder to film, that could be a lot of fun. Sometimes you can even find a diamond in the rough in movies like that. But something like Morbius, where you've got a multinational corporation funding it, and they just flopped, and then everybody convinced them. The only good part about Morbius is that everybody convinced them to bring it back to theaters, and then it flopped again. These individual things can be turned into functions, so yeah, it's just hard to watch. It's just, you're just like, what am I'm watching money burn, which could be funny in some instances, but all right, so let's just see. This one starts with FM1, 3, 4, 5, 6, 7, 8. So we're going to make a function for each of these. So we'll make, I'll get out of this and we'll give it its own section. Wavetablers. Void wtable. And then we'll start with, I think I just copied FM1. Wtable FM1. And we got to clean this up. Although technically I could probably take the for loops out of this. I should probably keep them in. Because then it would be just, this runs 256 rounds, and here's the, man, this could use a couple lines. Actually, we should start up here with the cleaner ones. Oh wait, no, these aren't the cleaner ones. Where are the cleaner ones? Void table set. These are waveform based on mode, wavefold. The mod value changes. I mean, this originally had a hard-coded wavetable, and I went through all the trouble to organize it, and it turns out it just calculates it linearly, so we don't need that. whole wavetable gets modified. Mod 2 wavetable and mod wavetable of I. So, well, what I was trying to do is to get the similar functions. Here's table set is done in multiple lines, right? So it's a little bit simpler. But then it busts out into this. Okay, let's see. So I'm just trying to rewrite table set. I need to table set mod 2 wavetable. This one's wavetable. Yeah, I shouldn't have grabbed mod 2. That was from a different part of the code. So this one is saw. And I'll just get rid of this. For 4. Saw. Let me do FM1. Or no, sine. Okay, so there's a couple different ones here. Void W table sine. You show him, Willow. You tell him. She is barking. It's like 70 out, so everybody is out walking their... What happened here? Everybody's out walking their dogs. War, war, war. That's all I hear. Positive half waves. We're being toxically positive, right? As I organize this code. Squaw. Screw. So, void W table SQU square. So much rewriting. Take it all back in. Using Shift Tab and then just Tab in order to move things in and out. Okay. Triangle. Void W table try. It's like there could be functions that do this in like in a library of some kind, like a math library or a chart library or something. Saw. Oops. Saw. Void W table. Saw. A chart library, yeah. Yeah. Get those charts. What are you? FM1. FM1. Void W table. FM1. I feel like a hacker. Bonk, bonk. Okay. Whew. It feels like I should be splitting these out though. Having them multiply this stuff in multiple steps so that it's easier to read, easier to follow. It would cost a couple cycles, I guess, of microcontroller, but I don't think that would be that big of a deal. Because like that is a sign of this whole fucking thing. It's so weird. Times 511. I might work to pull these out a little bit and make them a little bit neater. FM2. Void W table. FM2. Make a new variable and math separate. It usually fixes itself in the compile stage. Oh, that's interesting. I mean, I would keep the scope within the function, so maybe, yeah, it would be able to fix itself. I hit save and now everything's like lagging. There it goes, it's back. Jesus, dog. Everybody's walking dogs and stuff right now, so. This is FM3. Well, yeah, that, and I mean the RP2040 is like 133 megahertz. Like, like doing these calculations is nothing to it. W table, FM3. What up, esports? Okay, FM3, and then we've got if mode is equal to AM, but AM saw is exactly the same. We just double check. Well, this is saw, and then this is the new saw. That isn't even a saw. That's not saw. That is It says this is saw, but then this one is sine, and our sines are the same. So that one's the same. The next one, wavetable I sine blah 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 blah. That says it's FM1, which is not square, it's not triangle, but if we go down to FM1 and we compare them, same exact equation. I got you, I caught you. So that's FM1, FM2, FM3, and then we have new ones. So this is where we probably want, let's just double check FM3 to FM3. That looks like the same thing. Same thing, okay. So now we got a couple new ones here. I mean, we kind of are running it to the ragged edge because we're trying to get ADC resolution, but yeah, exactly. Doing all the business of this stuff and the calculations and stuff is like nothing. And all we're really doing is running PWM stuff in a weird way to make audio. Or something, something, something. Void W table FM 1 2 I guess. What a dumb variable name that is. Do that. Take them all back. Pop them up like that. Save. I would like to break these functions out and make them a little bit more understandable, though. The more I know about this stuff, the better I can edit things and make them sort of do my own bidding. It was inevitable that I would have to rewrite the software in my own sort of organization, just because that'll get me to know what's going on. Non-integer, yeah, so this is a non-integer multiple, FM2, and then it's void W table FM2 2. Looks like there's just variants on FM1 and 2 in these. I wonder what they would do in the other mode. Boop, 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 and then boop. Then we'll do a couple little boop, 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 and then boop, and then boop. W table FM2, W streamer. W streamers are so weird. 3, 2. And then this is non-integer multiplex FM3. Wait, I don't know if that's the right one. It wasn't. It wasn't. I almost had a cut paste error. Pop, 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 pop. Then finally, wait. Cheeky bastard. Wait a minute. This is with a different value. 7 to 11. 2 to 6. I just hate that we have to do the entire thing over again for a slight variation. Void W table FM3 3. But more differenter. Save. Okay. Sine 2 m pi I 256 256 256 2 times m pi 6.1.2 3.9 2.3 6.3 I 256 256 256 256 times 511 times 511 times 511 times 511. These add an extra integer, and then this adds a slightly different value to that integer. That feels like something that I could deconstruct and turn into the different things that it does. Like if I pull it out into steps, or if you zero out one of the values somehow, it feels like you could take this and make it into something that would generate the equation instead of having all of this code mess. Like triangle's unique, square's unique, etc. Saw sine, triangle, square, etc. 128 minus 511. Yeah, it seems like I could probably split this out and stuff. It would take a little bit of pen and paper to get that right. So if mode is equal to 2, case 0, and then we just run the stuff for all of these. So what I can do, I'm going to take both of these out and we'll destroy them. Make them a little bit more compact and readable. Take this, take that. Get rid of this stuff. Take out all the for loops. Let's just get rid of all that and just fix our switch case layout here. Actually, what I should do is split them out into functions. We have a function and then a like sub function and sub function. You know how it goes. Do and then if mode. So I'd rather have Depeche mode. switch mode, case 0, break, case 1. Does have to be indented? Mode is 0, mode is 2. That's all we have, 0 and 2. 2, and then we do void wtabler, and then this is mode select actually, mode cell, and then let's see. Actually, we could do instead of table set, I could do table set of cell mode. But then that would be an if this or that. So I'd rather, how would I do this? Because table, where are we running table set? We're running table set. Is that directly from our main? No. Modu set. Modu set does mode read, sets mode select. Once mode select is read, we do module set, and then that sets mod to some weird ass fucking value. And then who the hell knows what happens after that? Is that where we run into table set? Show me the table set. Or is it underscore? Yeah, table set sets the wavetable during setup. Oh, and when you push the button, if mode is equal to 0 or 2, it sets it to. Otherwise, the waveform is equal to 0? Push switch 0 or 1, when the push switch is on, waveform plus plus changes the waveform. Waveform's over 7, we reset it back. If the mode is equal to 0 or 2, then we table set. So if mode is equal to 0, then we wave fold. What the hell? There's so much going on. I wish I could reorganize this from the beginning. Okay, so we table set, then what are we doing? We're reading both the mode and the waveform, and we're setting it whether it's 0 or 2. Mode is equal to 0 or 2. So, and those are two different. If I do table 0 and table 2, because like that doesn't quite. All right, switch mode set. Oops, that's not right. Mode set case 0. wtabler 0. Break case 1. Or sorry, case 2. wtabler 0. It's gotta be a better way to organize this that I'm just not familiar with in my knowledge of programming. Table set, mode set, wtabler 0, wtabler 1, wtabler 2, why not? So wtabler 0, and then, Jesus, take the wheel, please. Void wtabler 2. End of the switch case. Actually, both of those were valid. Yes, okay. So we're getting rid of that, but then we call that wavefold mode. Switch, waveform, case 0, and then we go to this stuff. W table, saw. Saw, syn. Or really, it could be done by table too. We could have like a string table or a table full of function pointers would be a way to go through the 0 to 7 list and do it a little bit. How would I do that? Does anybody have a good example of something like that where you would have like a list of functions and depending on what number goes out, I bumped my elbow. Whatever value goes into the table, that's what the function uses. I think that's probably the way that I've seen it done in other stuff. Although that got a little complicated the one time that we looked at that, I believe. It's a shame these aren't the same list, because that would have further organized it. They're just similar. We have like a table of things that point to the function. What are we on? We're in triangle. Saw. Switch on enum. Well, what I was talking about is we would pass the number as a location of a table. Like the 0 through 7 would be the entry 0 through 7 on a table, and whatever that table or whatever has in it are all the names of the functions, and they run the individual function without having to have this kind of stuff. It would just be a way to organize a little more. Saw. Wait. We already have saw. We have saw at home. Saw, sine, square, triangle. Saw 2. Electric boogaloo. Saw 2. FM1. Oops. Barely listening. It's fine. It's fine. Yeah, these programming streams are not for the light of heart. They're pretty annoying, actually. Let's just make sure we're getting the right functions here. Saw, sine, square, triangle. Oh, it's octave saw. Saw 2. Octave saw. Ooh, tedious CAD work is rough. One of these days I'm going to have to reorganize. This one we go from saw to FM1, okay. I'm gonna have to build that Atom kit in CAD. FM2, and then we have FM3. Okay, and then, oh, I populated the wrong one. Damn it. It's fine. Oh, that needs to be indented once. So that's our switch case. Let's double check. If I get rid of that, then yeah, okay, cool. So they need to be. And then down here, we start out with saw, same one, and then we go to FM1. FM1, FM2, FM3 is 1, 2, 3. Then FM1, 2. I need to put semicolons after these. And that's why you guys don't tell me to do that stuff, because I'll figure it out in the middle of coding. FM22. FM32. FM33. And what trick does this one have up its sleeve? Why is it not? What's going on down here? Oh, that's FM. Hmm. 3.2, FM22, 3.2, and 3.3. So here I've got FM1, 2, 3, FM1, 2, 2, 3, 1, 2, 3, 1, 2, 3, and then 3. What did I miss? Saw 1, 2, 3, 1, 2, 3, modified 3. Saw. Oh, I skipped saw. Sigh. Brinks GG. GG. Hey, 11 months. One short of a year. Hell yeah. What's up, Copper? Brink, thank you so much. Thank you, thank you. Really appreciate the continued subscriptions. Okay, so wavetable saw. And then I gotta put semicolons after all these. There's a better way to do this. There has to be. Oh. We're trying to make heads or tails of the VCO code, the voltage controlled oscillator code, and it's using these crazy wavetables, and we're trying to learn it as we go, but yeah, I get that too. The item on the wish list spam. Was that the kickoff of the spring sale? Is it? It's not spring yet, is it? Oh my god. When did it become spring? I guess it's 70 degrees out already, which is not great. All my neighbors don't understand me at all. I'm out there going, you know, I'm a little worried about how warm it is. And they're like, no, but it's a nice day. It's like not one thought in their head. Oh, nice weather. It's nice out. It's like, I know you guys are going to shut off the mortal coil soon enough. It's a very old neighborhood here. As in the age of the people, the average age of the people here is pretty old. But like, I know you guys are on your way out, but man, like, it should not be as warm as it is. That goes all the way back to Void? Get out of here. And we got to take this whole thing and bring it back a little bit. It's a little crazy. March 19th. That makes a little bit more sense. This goes away. There. So we got mode 1 and mode 2. There's a much better way to organize this. Let me just look this up real quick. So it would be Arduino function list pointer. Not quite what I was looking for. int add, int divide, pointers to the function, arg1, arg2. Function pointers are useful for generic things. This is not what I was looking for. This is like base, this is like 101. Yeah, that's not, this is 101 stuff. I'm looking for a list of functions. Now I'm just gonna get, it's hard for me to describe because I don't know what exactly, it's like, from what I remember, it's like table of functions. Yeah, an array of function pointers. That's what I'm looking for. Structure an array of function pointers. That doesn't quite make sense to me. Type def void generic fp other reference to another forum that'll probably say this question's already been asked. Huh, that's a little different. That's an interesting way to do it. Functions in the define. I was looking to see more of like a list. Vector of, I don't know. It is not possible. Oh, okay. Call task 1, 2, 3. This is, I think, what I'm looking for. So I can invoke a function knowing only its index in the array. This is exactly what I'm looking for. Following Nick Gammon's example, blah 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 blah. Task pointer call task, type def void task pointer. For byte j blah blah blah. Call task j. Need index and extra bracket to call the function. I think that's what I'm looking for. Served me an ad for Wolfram Alpha. Oh, good. Their question ask bar to include the new AI chatbot. Oh boy. I mean, Wolfram was like one of the OG AIs, wasn't it? So is this actually going to organize things a little better? It just means that these sort of mid functions that I've got going on here, the table routing stuff, can get much more simple earlier. So if I do wfold pointer, it would be pointer. What is call task here? Type def void task pointer call task 1, 2, 3 serial begin blah blah blah, and then call task is the function. So wfold pointer, I'd have two structures in here, and so it would be call task. We'll just use their nomenclature. Task pointer call task of j. So it would be call task 0 and 1. Wfold pointer call task 1. And then in there I would have, oh, and I have an equals. I have an equals sign in there, and then instead of all the BS, it would be table saw, comma, oh, but without parenthesis. Syn. Damn it. Stop it. Saw, shine, square. Try. Saw 2. FM1. FM2. And then FM3. And then semicolon at the end of this. And then this would do mode set. It would be call task 0 of waveform. And then I give it parentheses because it needs that, semicolon. Call task 1, waveform, parentheses, that thing. It's likely that I could get rid of even this structure, this case structure. I'll move this stuff up in just a second, but for the call tasks, we then need saw, sine, squaw, tree, saw 2, FM1, FM2, FM3. Much cleaner. Much, much cleaner. That's what I'm going for. Clean! Make it clean. Okay. Let's bring these up further. Wait a minute, what just happened there? What did I get? Oh, looks like I had the same thing. Oh, yeah, okay, I did the wrong one. That's fine, we can just do this real quick. No! Well, if you like sociopathically organizing things, I got a wonderful task for you. Cleaning up code. Want a sense of order in your life? Learn how to clean up code. Nope. What did you do? Bop. Bop. See, that's how easy it is to edit the sequences now. So I'm going to take that, and we'll take that all the way up to the top. I'll put that in after my variables, or my settings rather. And then we need to do type def. W fold pointer. Like that. Let's do modes. There we go. Mods. Okay. Whew. So that supposedly sets it up so that we have a much easier to digest table of stuff. Although maybe I should put this in inits, because that is initializing the type def, right? I'll take these, put that below it. Okay, there. We've got it in the inits, and then we'll set up the tables this way. That's all I need to do, right? Task pointer is set up like that, and so I've got two different ones of these things that are set up as wfold pointer. Void call task 0, call task 1. Hopefully that does it. What's going on? I would trust Wolfram more than most to make an AI. Yeah. They've been using AI since like I was in college. Like it's this math AI. Shouldn't get ads, you're subbed. I'm out of control. If you get ads, it's completely out of my control, because I try to have an uninterrupted ad-free experience. That's how I like doing things. Hey Pyro, how's it going? We're setting up stuff that I barely understand, in code that I barely understand, in software that I barely understand. So what I just did now is I set up a type def of a void, which is a pointer to all of these different functions. And we just got that together based on, no, get out of here, based on this other code, where we can call a numbered task, because the button has 7 modes, and then the switch sets what bank of modes you're in. And so now we have a list of the modes like this that I can change on the fly if I feel like it. This code is from Hagiwo. I can show you guys the links if you feel like it. I don't know how much steam I've got left in me. I mean, we've got maybe a half hour of coding left. My voice is getting a little weird right now too. So, but yeah, here I need to put the links in here anyway. So let me open this up and find, first of all, the Hagiwo, the $9 Raspberry Pi VCO. Here, you guys can get the link there. I'm going to put this at the top of my code. My code. And then Hagiwo based his stuff on this, which is explainio how the math do. And then I'm going to do mutable instruments. And we'll take a look at, where did that audio come from? It was, one was marbles and the other one was, I think, it wasn't clouds. It was like the latest one that has, was it frames? No. Not links. Ripples? Nah. Are we edging? No. Grids? It might have been grids. This isn't the right page. Oh, did it? Yeah, did, no, that was a year ago. This is still up. GitHub.io. Is it? Yeah, oh, there's the sidebar. So, grids, let's look at grids. I'm just trying to find a relevant link to the schematic that I'm using so I can get all the documentation in there. Where are you outputting? Show me the output. Input. And the outputs are coming from a DAC. Nope. Back we go. Blades. Not quite, no. Braids might be it. This one has a huge LCD on it, but it also has this guy right here. And this is our audio output that we're following. So we'll include that in there too as part of our reference. There. Cool. Whew. Oh yeah, if you guys want to see the schematic, that's here. Oh, and then Hagiwo. I didn't share that with you guys. Wait, which one didn't I share? I did solder state N. I didn't do xiao. Automated Starship launch. I did not. I completely missed it. I slept through it by accident. Don't think I ever had to use an array of functions. Yeah, that's just how this wound up. I feel like I could probably organize it a little bit differently though, because these functions are just like, it seems like they follow a structure of different elements coming together. So if you take the sign of element times element times element, I mean 2 m pi I 256 sine 2 m pi, like you could probably structure that a little differently in order to get it to do the function that you want it to do, and have sort of a more generic way of calculating things that is a little bit more micro friendly. It seems like this was punched in there, you know, with the intent of a purpose in the end, but if you take it into sort of more microcontroller generic parlance, you could probably derive a function that would have, you know, a couple different inputs that you would give ones or zeros to, and that would do that particular step. Like if I give it sine of a sine 256, you could have like it zero out a piece of it. I would have to see what the original equations are supposed to look like, though. It'd take a little bit of pen and paper, but it would probably clean these up significantly, and you wouldn't have to have, you know, you'd have wavetable FM1, but then that would call a different function, and it would be a little bit more organized. Let the compiler do it. No, I can optimize. I'm smart. Oops. I forget where that came up, calling up an array of functions, but it's really useful when you have modes, so that you can just have your mode tables all the way at the beginning. And if you feel like changing stuff, you just kind of, you know, shuffle it. There's a lot more to go. I'm maybe going to look at this a little bit. I probably won't look at it tonight, let's be honest. I'm not going to be able to stomach this software until we work on it tomorrow again, and then I'll be scratching my head about what the hell's going on. But we're getting through it. We have a couple more things to do. There's a couple more areas that I kind of need to look into, and I need to look at things like where it's calling, what do you call it? Brain no worky. Where it is doing, yeah, the PWM stuff. That's all this that's been doing in setup, GPIO set function. And that's related to the library that they use. So we'll need to look at this and see what the hell's going on here, and figure out what stuff we can still pull to variables. Because like this is a little weird. 6 times I, 1230. If I knew what the functions were, then I could make variables that I would put up above in the defines, and that would help. It really helps if you do it that way, because then you have all your numbers at the top of your page. So if you need to change something that you think is a little hinky, it's right there, and it tells you what the number is supposed to be instead of it just being a number. And then when you go down and you look at the equation, you can say, oh, frequency 0 times the power of like the number of octaves times I over the number of samples. You would know that instead of seeing 12, 30, and 6 and having to loop back and figure stuff out. It's just a better way to program. Okay, I think I'm done for today. A little bit of programming goes a long way, and we've done a lot of organizing and a little bit of table structure stuff, and we didn't really get to run anything. I would love to be able to run stuff, but it changes all your numbers through all the equations. What are you talking about? No. If you use defines, you call your stuff. Hey, what's up, Uwo? How you doing, man? I've been tuning in and out of Uwo occasionally. Let's do shout out. Sorry, I've got a fangirl Uwo for a second here. That's why he comes here, for that fan service. Uwo's lab, Uwo slab. Go check out Uwo's slab. His slab has a lot of cool stuff going on. We've got a lot of cool stuff going on. Mostly me using my pocketbook in order to buy a $200 RC car because I got really pissed off with my 3D model of the WL Toys kit. Like, that wasn't supposed to happen. Why is the toe-in so bad? This thing is rip-roaring stupid fast, and I'm gonna probably get outside with it at some point and see how fast it goes. It might be on the order of 75 miles an hour, but I bought an expensive kit and I kind of put it together and then 3D modeled where all the electronics would go, and now I have this pretty tidy looking little RC car. So I'm gonna take it out and drive it outside and it'll explode, and then I can buy some of the replacement parts and maybe thicker tires. I mean, keeping up with the RC car project, this thing is nuts. And what I don't understand is why I have look at this, 1 millimeter. What is that? Sorry, this is the part where I'm so ticked off at coding that I just can't concentrate anymore. I've been coding for like 4 hours. I'm done for today. But why do I only have 1 millimeter of travel on this thing? It's so weird. Oh yeah, and all the hair everywhere is inside of the hubs now. I've been running it on the flat floor behind me, and I've got barely any room for it, but the problem is during the day I'm giving my dog walks, and I don't want to go outside with her with this because she has like a torn ACL or a tearing ACL, and she has to kind of take it easy. But yeah, the electronics. Well, DOS Micro is one of the main reasons that I got these so compact. If DOS Micro comes out with new stuff, because this is bad. I wish I could use that. If I was actually going professional and I was racing these things, there are $14 for 3 of these motor controllers on, I think it's Amazon, and I'm looking for it right now. Hold on, let me go get one. It's this really thin motor controller that I don't know where it is. All right, come on, just find a stupid thing. Where'd it go? What'd it do? Can't find it. Anyway, it's a very thin motor controller. This one's a little thick, but Willow's injured. Yeah, she runs too fast. Oh yeah, I also have an FPV camera too. Fun stuff. These are all my disgusting broken parts. Previously, we had built a motor controller, but this thing is just dead. It doesn't quite work. I bought these super fancy, not super expensive, but super fancy. Oh god, that's disgusting. These super expensive MOSFET drivers that are these little guys right here. These are the MOSFETs. I bought these. I looked at the new tab on DigiKey, which is dangerous. I bought a few of those FPV cams for bots. It really adds to the stream. I need to get the analog video switcher so I could do something with this. But yeah, that sounds fun. The last time I watched Uwo's lab, he beheaded a VTuber, which is always a fun thing to do, and I recommend it. But yeah, so we have these MOSFET switchers that should switch these MOSFETs. Yeah, this is a custom board. This is the 8-channel receiver, and then the gyro was going to go there. And then on the other side, I have an ATtiny85 that we exhaustively programmed in order to be configurable, etc., etc., etc. But in the end, when I finally got this thing working, I accelerated with the motor, and it didn't go at all. So I said, screw it, we're going to get a 3-phase motor controller on this thing. And so I got a 3-phase motor, and this is a 9500 kilovolt motor with way too big of a pinion gear. I've flowed a lot of that. It's very easy to do hand soldering if you don't have the super duper iron, and if you don't have hot air. You can reflow with a toaster oven, you can reflow with a bunch of different stuff. And the fun part is you can just drop the solder paste down and it pretty much organizes itself. You got to be careful about exactly how much you're putting down, but it's very easy to just plop down the solder paste, move the components over. And I actually have a variety. I had a user send in an entire oven. So I've got a big soldering oven that you can program. But in the future, when we actually build a bunch of these VCOs, I have a hot plate that's actually, it's in the cabinet now. I have like a hot plate that we can use so that we can use the microscope and we can get those ooh-ah gifs of everything flowing over suddenly, and then all the components like racking themselves into place. Yeah, the toaster with a PID oven, that's what I would use. And then this user sent in I love that they sent in this really expensive oven, but it was a little bit tone deaf because the oven has a viewing window that's this big. And we hacked the oven, that's cool, but I can't get it on camera if the window is this big. So I have a toaster, it's sitting in the back of the shop. I would like to put a PWM controller on it, but I've got a professional oven now. So what, should I do that? I should do that because then I can get this camera and the microscope to view in the big glass on the front of the toaster. It's just considering that streaming is a totally different animal than actual electronics manufacturing. There are things that I do and I skip in order to have the haha funny stuff goes wrong phase of building a project where I have to think on my feet. The thing that we were working on today is doing the code of a design by a YouTuber named Hagiwo, based on a different project. Basically what happens is you've got an RP2040, you send out a PWM, you change the frequency, and I guess whatever the interruption of the PWM frequency is, and you send that through a filter and it makes an audio frequency. So what we can do with a $5 microcontroller is we can have multiple control voltage inputs, multiple user meat space controls, like a button, and potentiometers all going into this device. This reads it and it outputs stuff. So that's the voltage controlled oscillator element. We did circuit design, we built the circuit, unfortunately on a kind of an ugly circuit board color. The yellow ones turned out a whole lot better looking. These look a lot nicer. Yeah, these please the meat in meat space. But yeah, the yellow circuit board we will work on once we get our initial code down, because Hagiwo based it on somebody else's design and got blocks of code from somebody else's design, which was in a different microcontroller. I need to turn it into Arduino code, right? Yeah, that's my impression, was that yellow was going to look horrible, but the contrast from the FR4 to the copper is so good. It's a weird shade of yellow, but it's actually really nice. And then the silk screen for Seed Studio. I use Seed Studio, it's just who I use. There are other places to get circuit boards. There are better and worse ones. Seed Studio starts to get blurry when you get below certain sizes. Their things get blurry. But yeah, black circuit boards, you're basically just relying on the embossing reflections to see where your traces are going. Otherwise, they are completely invisible. So, also the camera hates it because the camera thinks there's not enough light going in. So we took parts of mutable instrument circuits and we applied them to Hagiwo's design. So we have a Salin low-pass filter, Salin key low-pass filter going into amplification. I hope that's performing the same function as this filter right here. Otherwise, I'm going to have to build that filter in our circuit. Yeah, the cheaper yellow PCBs will do the same thing that white black does, which is just completely Xerox over any of the circuit elements. I'm not sure if white looks the same or not. I'm not totally certain about that. The board was done in Fusion 360, and the hardest part about Fusion 360 is in order to get a beautiful 3D render of your board, you need to painstakingly get all three-dimensional parts, which means going to GrabCAD or the manufacturer's website or just DigiKey and getting all these models in. And then you've got 100,000 files, because you have a file for the 3D model, you have a file for the 3D model on the footprint, and then you have your library file, and then you have some other files that you can't delete for some reason. It's ridiculous. It's stupid. But yeah, this thing looks awesome. Yeah, it's a big pain in the ass. Once you get sort of the sequence of steps, I've had a couple of streams where we were building these boards where I've kind of gone over it. But once you get that sequence of steps and you spend the effort for it, you get a beautiful 3D model of the actual board, which is why I was able to make these 3 boards in Fusion. Not entirely, just enough so that I can do this design. And I was able to put them all, make them all into a press fit circuit board holder for the RC car. If I was a little bit more of a clever boy, I guess I could probably have put like electronics in these little outlying areas. Like the radio and the motor controller can go pretty much at any orientation. If DOS Micro was able to build a smaller 3-phase controller, maybe I could find one somewhere. Or if I use the one that's just a line, it's like a drone controller. It's super cheap. But that one doesn't have reverse. I need reverse because I'm bad at driving. But I could probably hide some electronics like here and over there. Anyway. Yeah, I use Fusion for all of my CAD work because it's free, and I have an educational license. I'm totally an educator. I educate on Twitch. I didn't lie to them in any of the documentation. Look at this RC car. Isn't it shiny and cool? What a neat design. Wood-based circuit boards. You could PM me on Discord, and I'll tell you what I did. But I got an educational license to Fusion, which means I don't have to do some of the where are your students? You shut your mouth. You shut your stupid mouth. Stop it. Anyway, so yeah, so the educational copy gives me some access to like really crazy features. Although if you use too much generative design, they'll flag your account. So it's like I don't want to gain their the Eye of Sauron to be upon me. And to re-up your education version, you just kind of click one button. So, but yeah, if that blows up in my face, I will use the free version of Fusion until it pisses me off. Because Eagle is part of Fusion, and I know Eagle. That's pretty much it. Trying to learn FreeCAD. Yeah, I would suggest learning FreeCAD. Drexel University 10,000 years ago taught me AutoCAD back when it was a command line. And so I think in that way. I think in, here's a flat sketch, extrude the sketch, chamfer all the edges, we're done. Like, that's pretty much how I think. So I'm getting educated. Yeah, see, there you go. There you go. That's it. Dip Trace. Is that one of those super expensive ones? I've been meaning to learn one of those amazingly expensive programs that are like $800 a month. They go up from there too. There's like $2,000-$3,000 a month CAD programs that are like infused with AI and stuff like that. All I know is Eagle. All I know is Eagle. And in Eagle, what you do is you put the schematic down, and that programs the CAD software as to what thing is connected to thing, and then you go over to your air wires and do all that stuff. It's fairly simplistic. I mean, I cut my teeth on like PCB 123 and Free PCB, I think it was, where it's literally just MS Paint but for PCBs. Dip Trace is affordable. How much does that cost? How much does that cost? Wait, I didn't christen the schematic, did I? Where's the... Almost every single... How could I allow this one to go unscathed? I have to edit this file. Hold on a sec. We need to set this straight. This is unacceptable. Those are my bouncers. Hold on. I'm bouncing on my boy. Let's see. Going to... Project. Stream. No, just synth. Not mod synth. Synth. And then we have... It's very organized. Where is that? RP2040 VCOs. Edit with Notepad. No, not Notepad. That's the... No. Stop it. Stop. Oh, God. It's all gone awry. It's all... Oh, okay. Notepad, please. I don't need you to crash right now. Okay, while that's figuring out what the hell's going on... Nope, never mind. Can't use my computer until this thing is done figuring out that it hates... You don't have to open it, Notepad++, please. Spare us. I'm so dead. Okay, I'm gonna wait for my computer to sort itself out. Okay, we're back. Well, Notepad++ isn't back. I've done something incredibly cursed and Notepad++ is making me pay. It's been flashing and doing weird stuff. Okay, let's get back here. Why did you do that? Get out of here. Jesus. Okay. I'm going to have to do like an exorcism on my computer now. Just edit. Oh, there we go. So first off, nope, a little bit more room. Oh my God. Oh, we're a little bit frozen. I'm still here though. OBS is still priority. Okay, there's that again. Don't know where that came from. Hey, Notepad++. You're a very good program, but let's just close that. I got my hands up. I'm not touching anything. 3 PCBs for 55 back when that was impressive. Yes. Yeah, I've built quite a few little PCBs on that program. All right, let's crop this. And since this is BotherCAD, I mean, we can't avoid it. I don't know why I didn't do it before, but we just go down here and we just give it a little. Here we go. Okay, cool. Now I can save this. This is our master document. This is basically the napkin sketch. And the fun thing about the way these PCB houses have influenced design is that you go from your napkin sketch to CAD, order the board. I mean, basically the way that it should work now is you go napkin sketch to solderless breadboard, where you can just punch the components down, connect them, figure out what the weirdnesses are, refine your code, and then load your code up, get a functional breadboard circuit, a solderless breadboard circuit, and then you can go to CAD and you can make your design. We went directly from our napkin to CAD, and then we built our design. And then it basically, I mean, like, I'm a little worried because if that PWM doesn't actually go into the Schmidt, or sorry, the Salin, keep calling it Schmidt, Salin key filter properly, we're going to be SOL. We're not going to make audio frequencies, and I'll have to create that filter again. I think, not really knowing anything about Salin or what they're about or what kind of shit they're into, what their kinks are, I don't know if this little low pass filter is equal to this slightly more complicated op-amp filter. Mutable Instruments makes these wonderful modular synthesizer modules, and so we've been copying Mutable Instruments stuff for their quality, and then Hagiwo has these really clever, very, very cheap designs that fill me with trepidation, like having the BAT43s do all of your filtering, keeping your 3.3 volt device from a gruesome death at the hands of plus minus 10 volt synthesizer voltages. Instead, I'm a little happier if I have some kind of an op amp in that process. And what Mutables does was of our doing they have an AREF negative 10 volt being applied to your plus minus 5 so that it's 0 to minus 10, right? So you're adding these two up, 0 to minus 10, and then you put it through an inverting filter at a 1 to 3, or 1 to whatever, 0.3. So it is a third of that voltage, which makes it 0 to 3.3 positive volts going into your micro. And since you're an MCP 6004, that thing's getting in 3.3 volts, doesn't quite go all the way to the rails, your microcontroller is safe. When you're working with VCO and filters, the breadboard traces mess with it. It's better to proto directly. I have not fully explored that, and I have a ton of parts that I could, do the through-hole stuff with, and it does mess with it, especially if you buy these quarter-watt resistors. These things suck. They're great because they're accurate, but I hate through-hole, and also they sometimes don't exactly, because all this thing is, okay, so you guys should know, everybody in chat, you guys should know, a solderless breadboard is just a clip. And it's like a hair clip. It's like two sides of this thing have been bent into a little clippy guy, right? And they've got little segments to them. And so when you press your thing through here, you're relying on that clip to kind of pinch the line. And it doesn't do it very well for the thin wire. So sometimes when you put your thing together, you'll like wiggle the parts in order to get it to work. And I was experiencing that even with wire wrap when I did that in the early 2000s in college. Wire wrap, well, that was the late 2000s in college. Wire wrap, you would put a pin header in and wire wrap that pin header and then put your components like this, the ones you change out, onto that pin header, and then you would push on it and it would change like properties and values, and your circuit would work or not depending on how you push down on the circuit. Ugh. They're good simulators that test surface mount stuff, or is there a way to use SMD on breadboards? You can use a pin header and you can solder stuff directly to a pin header if you feel like doing that. But simulation goes as deep as you want it to go depending on your budget. Doodle to PCB directly, it's so cheap. $5 for 5 PCBs if you keep it under 100 by 100. Like, sign me up. It gets here in a week. I'm done. That's it. Like, the new processes are so wild. Panelizing and the popularity of this hobby has helped quite a bit with that kind of stuff. Yeah, for somebody who was around, I don't know how long Uo's been around. I think he's a fetus. No, he's probably older than I am. But it totally changes the game having $5 for 5 PCBs. I was like, $55 for a PCB. That's amazing. All I have to do is refine my design a little bit more, then I can order it. And now it's 5 for 5. It's just a fucking orgy out here. Like, you're just, oh, give me a PCB for that. I don't care anymore. Like, oh, that's a bad design. Fine, throw it in the trash. Like, what the hell? It's so weird. Mid 2000s when I started being online in the hobby. Yeah, for me it was the 10s actually is when I started being online. Yeah, you'd have to figure out what a full panel price is. Now they just hit like actually I don't know if they do anything. I think it just all poops out of the other end of the machine. Cause like even the panelization is automated and stuff. So it's like there's like nothing to the process. It just poops out the bags that have to be taken over to the mailing area. Totally crazy. All right, I am burnt out on coding, so I'm going to take a little while to look at something far away, pet a dog, take a dog for a walk, eat some food. Maybe I'll be back at it. I'm not sure. Been trying to learn KiCad because of mechanical keyboards, only to realize that I'm better off just buying a TKL with a separate numpad. You got, okay, so everybody loves their spreadsheets. Everybody loves the cost of a project. How much did that cost you to make? Where did you get that costume? And I say, I bought it on Amazon, and that shuts them down, and then I don't have to talk to them. But if you take your projects, if you take something like, you know, the RC car project, and you put that on a spreadsheet, and you look at that spreadsheet, and you go, oh my God, did that cost me that much when I could have gone somewhere else and gotten it cheaper? Don't do that, because yeah, exactly, the cost is the friends you made along the way. The cost is along the friends you made the way. The cost is the skills that you're getting from doing the project, doing the entire process, doing the solderless breadboard, solderless breadboard, perforated prototyping board. Doing the perforated prototyping board is an important thing to learn how to do, because if you need to make something on the fly that will repair something else, or if you need to use the solderless breadboard to test something that you don't have in through-hole, those are all skills that you will need along the way. So there's a reason for doing all of this stuff and not counting every single individual resistor that you spend along the way, because there's a whole nother human factor involved in it. How much entertainment did you get while doing it? Did you learn new skills? Did you learn something cool? Did you get a cool, sweet looking like burn scar on your hand? Those are all important facets to factor in, not just the economical thing. Because I mean, China's like blown that. So many facets of electrical engine, the hobby of doing EE stuff, right? China has just blown it all up, right? They have taken the cost per something, lowered it down to the basement. They've taken the cost per circuit boards and made it into like unfathomably cheap territory for boards that look pro. You can buy your whole project already built for so cheap. You gotta have fun, you know? So it's just like, it garners, just ignore it. Just ignore it. Try to learn some of the shortcuts. Oh, for KiCad? Yeah, I'm sure there's stuff in Fusion that I could be doing that would help me out a little bit. Most of the struggle with Fusion is not in the design, though. It's in the getting your stuff into Eagle so that you can build, because the whole powerful thing about Fusion 360 is that you can build your circuit board and you can make the cool looking rounded edges, but then you can also take the locations of all the stuff and plot that out to make your front panel, and your electronics agree exactly with your layout to where everything fits just right. So being able to design something in Fusion and hitting Control P on the printer and then putting it up to something that a completely different manufacturer built and having it line up in this manner. I mean, these switches are a little bit taller than what I expected, but otherwise it's fine. That's an amazing thing, and that's kind of where we are with this hobby these days. It's nuts. And the only reason I learned all this is because chat had pushed me to getting a 3D printer and maintaining it and keeping that up to date. Otherwise I would be ordering the boards and like drilling a panel, and without the DRO, because that's broken, there's no way, there's no chance that any of the holes would line up to where they should be. Okay, anyway, we're spinning our wheels here. Pardon the race car parlance. But yeah, tomorrow, I'm coming back tomorrow. You better expect me. Yeah, I'm gonna go pet the puppy dog because she has less expectations of me using my brain. But we're gonna still be working on code because we need to get it working. And at some point, it might take totally rewriting it or just going through, part by part in order to get the logic down. I apparently don't get a ton of viewers. It's like a totally different set. Like, there's different people watch different stuff, and I think I get a lot of the coders when I do programming, and it like changes chat a little bit. It'll probably be a quiet Friday where we just hump software until it works. When it works, that'll be a glorious time, because then we can start working on the chord VCO and figure out how the hell that thing works, because it's going to be a totally different animal. Modestly the same, but you can see I'm like having trouble finding words. So we're just going to do the end card. Here's my info. Like stumbling over my words and stuff. I need to like talk slower. Hello, it's me. Oh bother. Here are my socials. Yeah, you missed your opportunity because I'm going a mile a minute. That's the problem, is I start blah, 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 blah. So I'd rather get a slow southern accent, I think. Maybe I could talk like this during streams, and you all could listen to the dulcet tones of Oh Bother. I'm not gonna do that.